Hello there, and welcome to the Sleepy Facts channel. Tonight, we drift together through the soft edges of the unknown, the places where light fades and knowledge begins to dream. This is a journey into the mysteries science has yet to solve, the quiet questions that hover just beyond understanding. For centuries, humanity has searched the night sky and peered into the smallest particles of matter, hoping to uncover a final truth, a key to all things. Yet even now, after all our telescopes, our equations, and our experiments, there remain spaces untouched by comprehension, places where data grows silent, and all that remains is wonder. Science is not the end of mystery. It is its continuation. Each discovery expands the horizon, revealing new questions we had not yet thought to ask. The unknown is not a void, it is a sea, shimmering with possibility, and every so often, we float quietly upon it, listening to the universe hum beneath our thoughts. As you settle in, feel the slow rhythm of your breath. Let your shoulders release the day. Allow your mind to soften into the calm simplicity of curiosity. You are not required to solve these mysteries tonight, only to hear them, only to rest in their presence. Even now, as you listen, science is unfolding in laboratories lit by pale blue light, in observatories cradled high on mountain ridges, and in the silent motion of space probes drifting far from the warmth of the Sunday. Somewhere, a physicist is measuring ripples in space-time, hoping to glimpse what gravity truly is. Somewhere else, a biologist is staring into a droplet under a microscope, watching molecules behave as if they remember something ancient. In another room, a neuroscientist studies the human brain, mapping electrical storms that flicker like constellations yet cannot tell you where a single thought is born. For every triumph, there remains a question that lingers like a breath on glass. We know that the universe began with a great expansion, but from what and into what? We can trace the origin of life back through billions of years of evolution. Yet the first spark, the moment chemistry awoke, hides in shadow. We can model the shape of galaxies and the pull of gravity, but the invisible matter that holds them together refuses to reveal itself. Even the experience of being the feeling of awareness, the quiet I am that watches from behind the eyes, is a phenomenon no formula can contain. It is tempting to think of science as a ladder, something that climbs toward completion. But perhaps it is more like a spiral. We return again and again to the same mysteries, seeing them from slightly higher vantage points, deeper layers of clarity. The pattern remains, but the view expands. As the night deepens, we will wander through 100 such mysteries, the ones that whisper between the stars and under the skin of the world. Some are cosmic, spanning billions of light years. Others are microscopic, smaller than a breath. All share a single truth that we do not yet know, and that is what makes them beautiful. The unknown is not an absence of knowledge, but an invitation, a place where imagination and observation meet, where a child's question, "Why does this happen?" grows into an entire field of study. Every equation begins as a wondering, every theory as a dream. Consider, for a moment, how strange it is that anything exists at all, that atoms, which are mostly empty space, can come together to form oceans, planets, and the delicate machinery of life. That light, which travels endlessly, can be slowed, bent, or trapped in the gravity of a star. That the same elements that burn inside the hearts of suns also flow quietly in your veins. Science has explained much of how these things work, but not why they should be this way. Not why the laws of physics allow such elegance, such improbability. The philosopher might call it chance. The scientist might call it the fine-tuning of constants. But to lie awake and listen to these thoughts is to feel something older than either a reverence for the impossible made real. Some mysteries are vast, written across the sky, the origin of the universe, the fate of time itself, the dark energy that drives everything apart. Others are quiet, folded into the living world, the reason we sleep, the nature of emotion, the strange persistence of memory. Each one tells a story of boundaries reached and questions left open. There are mysteries we can describe but not comprehend. The duality of light, behaving as both wave and particle, the entanglement of particles that seem to communicate instantly across space, defying the speed of light, the collapse of a quantum wave when it is observed, as if awareness itself alters reality. These are not errors in our understanding. They are glimpses of a deeper order, one that does not fit neatly into words. And there are mysteries of the heart, of consciousness, of identity, of feeling. How a collection of neurons and chemicals can give rise to color, sound, and thought. How love, a pattern of molecules, can feel infinite. How grief can bend time, making seconds feel like years. Biology describes the process, but not the experience. The story of being human remains one of the most profound frontiers of all. The closer we look, the stranger things become. The smallest particles flicker in and out of existence. Space itself may be made of discrete units, tiny quanta of geometry, vibrating in a pattern we cannot yet see. The vacuum of nothing may contain enough energy to birth a universe. The fabric of space-time hums with ripples that pass through us constantly, stretching reality itself by infinitesimal amounts. And yet, despite this strangeness, there is peace in not knowing, in recognizing that mystery is not failure, but belonging. The unknown reminds us that we are part of something vast and unfinished, that we live inside a story still being written, moment by moment, by the quiet hands of time. So tonight, as we move slowly through these 100 questions, let the sound of wonder lull you into calm. Let each mystery wash over you like waves upon a dark shore. You do not need to hold them all, they will hold you. Because in the end, the purpose of knowledge is not to erase mystery, but to deepen it. Every truth uncovered reveals a greater strangeness beneath. Every solved equation points toward a deeper riddle. The universe is not a puzzle waiting to be completed. It is a melody that plays forever, changing with each listener. And somewhere in that endless song, we find ourselves small, curious, and awake in the dark. Now, breathe deeply. The night is patient. The stars are listening. Let us begin our quiet descent into the unknown, the places where science still whispers, not yet. 1. The mystery of consciousness. No matter how far science has wandered into the wilderness of the unknown, nothing remains as strange or as intimate as the mystery of consciousness. It is the most familiar thing in the universe, and yet the least understood. It is the quiet light behind your thoughts, the presence that listens when there is nothing left to say. You cannot touch it, weigh it, or measure it directly. You can only be it. And though we live our entire lives within its boundaries, no one can quite explain what it is or why it exists at all. In laboratories around the world, neuroscientists map the electrical storms that ripple through the human brain. They can record the sparks that accompany emotion, language, and memory. They can track how perception forms, how the eyes translate photons into signals, and how those signals weave themselves into images of the world. They can even locate the regions responsible for awareness, the networks that light up when a person becomes conscious of a thought. And yet, after all that measurement, one question remains, untouched. How does matter become mind? This is known as the hard problem of consciousness, a phrase coined by the philosopher David Chalmers. The easy problems, if such things can ever be called easy, are about function, how we see, how we remember, how we move, how the brain processes input and makes decisions. The hard problem asks something deeper. Why does any of it feel like something? Why isn't the brain just a machine made of quiet switches and signals? Why does it generate a sense of being a self, a presence, a first-person view of the world? Even now, with all our instruments and equations, science cannot say. Some researchers believe consciousness is an emergent property, that when a system reaches a certain complexity, awareness naturally arises. Others think it might be fundamental, woven into the universe like space and time themselves. A few have even suggested that consciousness could be a field, like electromagnetism, existing everywhere, manifesting more vividly in organized structures like brains. But these are ideas without proof, sketches on the edge of comprehension. When you close your eyes and think of a memory, what is it that looks inward? There is no small observer in your skull, no single neuron that holds the key to experience. The brain contains billions of cells, each firing in rhythmic patterns. Yet somehow, within that storm, there is a stable center that says, I. The sense of being someone, the experience of having a point of view. Science can describe how neurons interact, but it cannot yet explain how that interaction produces the taste of rain, the sound of music, or the warmth of a memory. Some experiments try to approach the mystery from the outside. Monks in meditation, hooked to EEG monitors, reveal brain waves slowing into gentle harmony. Patients under anesthesia drift into silence, their neural networks disconnecting from one another like dimming constellations. As consciousness fades, activity patterns flatten and fragment, like an orchestra whose instruments fall out of sync. But when the person wakes, the music begins again. Somewhere between those two states, the deep sleep of the body and the awakening of the mind, lies the invisible spark that no machine has yet captured. There are theories, and each one opens a door into deeper questions. The global workspace theory imagines consciousness as the spotlight of attention, shining upon the brain's stage. Countless unconscious processes happen in the wings, but only those illuminated by awareness reach the mind's theater. Another theory, integrated information theory, suggests that consciousness arises from the way information is connected, that awareness grows as systems become more unified, more entangled in their own complexity. According to that idea, even a simple circuit or a single-celled organism might possess a faint whisper of experience, a dim spark in the dark. And then there are the dreamers, those who wonder if consciousness does not belong to us at all, but to the universe itself. Perhaps we are not generating awareness. Perhaps we are receiving it, tuning into it, like radios catching a cosmic broadcast. Our minds might be instruments, not sources, temporary arrangements of matter through which the universe becomes aware of itself. It is an idea both poetic and humbling, and though it stretches beyond the reach of experiment, it echoes in philosophy, in mysticism, and in quiet moments of wonder when one feels the boundaries between self and world blur. What is it like to be conscious? It is to feel the passing of time, to know joy and sorrow, to recognize the color blue and the meaning of music, to love, to remember, to imagine things that do not yet exist. Every one of those sensations arises from patterns of electricity, but there is something in them that no equation can replicate. A computer may simulate perception, but it does not feel it. It can describe a sunset, but it does not see. Scientists have built machines that mimic certain aspects of awareness systems that can learn, adapt, and even hold conversations. But whether they are truly conscious remains unknown. They can process data faster than any human mind, yet there is no evidence of an inner world behind their circuits. No flicker of wonder, no sense of being alive. The question of whether artificial consciousness is possible may one day force us to redefine what life itself means. For if awareness can arise from silicon as it does from carbon, then perhaps consciousness is less about biology and more about pattern, less about what something is made of, and more about how it moves, connects, and reflects upon itself. But what if awareness is not a switch that can be turned on or off? What if it is a continuum, an ocean with depths we barely know? From single-celled organisms responding to light, to animals showing empathy, to humans dreaming of eternity. Perhaps consciousness is a spectrum that runs through all of life, each form reflecting a different note of the same universal chord. If that is true, then we are not alone in awareness. The forest feels in its way. The ocean remembers. The stars themselves may hum faintly with perception. No matter how the mind is measured, its essence remains slippery. Neuroscience may one day map every connection in the brain, yet still fail to capture the taste of chocolate or the ache of nostalgia. For consciousness is not the data, it is the experience of data. It is not the neuron, it is the meaning that flows through it. Science describes the mechanism, but consciousness is the melody that mechanism plays. Perhaps, in time, we will find a bridge, a unifying law that connects physics and awareness, matter and mind. But for now, the question rests softly in the space between observation and silence. Why does the universe bother to experience itself at all? Why isn't it just matter in motion, blind and unfeeling? Why, among the infinite cold of the cosmos, does there exist something that can say, "I see," as you drift toward sleep? That question lingers. Consciousness, after all, is what experiences both waking and dreaming. It is the gentle thread that continues unbroken between the two. In dreams, the brain creates entire worlds, populated by voices, landscapes, and light, all from within itself. It cannot tell where imagination ends and reality begins. When you awaken, the world reappears, and you never quite know if it was gone or merely waiting. In that way, consciousness may be the universe dreaming of itself, each mind a brief flicker in a vast, ongoing thought. Every moment of awareness, a ripple on the surface of something immeasurably deep. So, as you lie still now, feel the quiet pulse of that mystery within you. The awareness that listens, the listener that no science can define. It is the oldest thing you know, and the strangest, the presence that has watched every sunrise you have ever seen, that has drifted through every dream, and that will, even in silence, continue to glow. Whatever it is, chemical, cosmic, or eternal, consciousness is the first and final frontier. And though we cannot yet explain it, perhaps that is part of its beauty. For if everything could be known, the universe would be only fact. But because there is mystery, it is also alive. And you, drifting now in the space between thought and sleep, are part of that same living mystery, a moment of awareness in an endless sea of being. 2. The origin of life. Long before the first heartbeat, before the oceans glittered beneath the sun, before breath and hunger and memory, there was only chemistry. Molecules drifted in a quiet sea, colliding by chance, dissolving, reforming. And then, somewhere amid that slow chaos, something impossible happened. Matter began to remember itself. The lifeless became living. The universe learned to grow. We have named this transformation abiogenesis, the emergence of life from non-living matter. It is one of the most profound mysteries science has ever faced, a doorway through which every organism, every forest, every human being has passed, and yet no one knows what pushed it open. We can describe how life behaves once it exists, but not the precise moment when it began. That instant remains suspended in deep time, unrecorded, unrepeatable, and endlessly astonishing. The Earth formed more than 4.5 billion years ago, a molten sphere cooling beneath a newborn sun. Volcanoes poured fire into an atmosphere thick with carbon dioxide, methane, and water vapor. Lightning danced across the darkened sky. Oceans gathered in the planet's low places, filling with minerals, salts, and organic molecules raining down from space. The conditions were violent, but fertile. Chemistry was awake. In that primordial sea, molecules did what they always do. They interacted. Carbon met. Hydrogen, nitrogen, found oxygen. And together, they built increasingly complex structures. The universe, left alone, is a patient artist. Even without intent, atoms will seek patterns, binding where energy allows. Over countless ages, these simple molecules began to assemble into chains, amino acids forming proteins, lipids forming membranes, sugars forming the backbone of RNA. Each reaction was a small step, a flicker toward order amid the chaos. Theories abound, and each one feels like a fragment of a larger story. Some scientists believe life began in deep-sea hydrothermal vents, where mineral-rich water gushed from cracks in the ocean floor. There, protected from the harsh surface, heat and chemistry mingled to create pockets of possibility. In that darkness, molecules may have clung to mineral surfaces, copying their structures, catalyzing reactions that slowly gained complexity. Others imagine a world born of shallow ponds, warmed by sunlight and stirred by rain. Perhaps lightning or ultraviolet light powered the first reactions, stitching together fragile molecules that learned to endure. There is even a theory that life began elsewhere, that the seeds of biology arrived from the stars. Comets and asteroids carry organic compounds, frozen fragments of cosmic chemistry older than Earth itself. Some scientists suggest that when these celestial messengers struck the young planet, they delivered the ingredients, or even the first living cells, across the endless dark. If true, then every living thing on Earth may be part of a larger lineage, one that began long before our world existed. But no theory has yet captured the full miracle. We can recreate parts of the process, amino acids forming spontaneously in laboratory flasks, lipids self-assembling into microscopic bubbles, yet these are only pieces. The leap from chemistry to biology remains invisible. How did mere molecules learn to copy themselves? How did replication, the heart of life, arise from random reaction? In the 1950 seconds, Stanley Miller and Harold Urey conducted an experiment that changed everything. They built a sealed glass chamber filled with gases thought to resemble the early Earth's atmosphere, methane, ammonia, hydrogen, and water vapor, and sent electrical sparks through it to mimic lightning. Within days, the clear liquid inside the chamber had turned pink. When they analyzed it, they found amino acids, the building blocks of life. The experiment proved that under the right conditions, organic molecules could form naturally. But it did not explain how those molecules learned to live. For life is not just chemistry, it is persistence. It is organization, memory, and motion. It is the ability to repair, reproduce, and evolve. Somewhere, long ago, the first molecular systems began to do these things. Perhaps an RNA molecule found a way to copy itself. Perhaps lipid bubbles protected those fragile strands, giving them time to grow and change. Perhaps those molecules began to compete, the most stable, surviving, the most efficient, replicating faster. Slowly, through trial and error, written across eons, the first cell may have formed a tiny capsule of order, surrounded by the vast disorder of the sea. That cell would have been unimaginably simple. A droplet of chemistry containing a few strands of information, enclosed in a membrane. It would have fed on the energy around it, dividing when it grew too large, passing on its pattern. And from that first fragile division, a lineage began. Every plant, animal, and microbe alive today can trace its ancestry to that single spark, that moment when the universe began to know itself as alive. Even now, we are not certain what life truly is. We can define it by what it does. It grows, consumes, reproduces, evolves, but those are descriptions, not explanations. A flame grows, consumes, and spreads, yet it is not alive. Crystals reproduce their structure, yet they do not think or die. Life seems to exist in a delicate space between chaos and order, too organized to be random, too flexible to be mechanical. It balances between structure and freedom, between repetition and change. Some scientists suggest that life is simply what matter does when it organizes itself in certain ways. Others believe that life represents a deeper principle, the universe's tendency toward complexity, a natural outcome of physics itself. The cosmos may have been destined, from the very beginning, to produce observers, to produce beings capable of wonder. If so, then life is not an accident, but an expression of the same law that builds galaxies and stars. Still, the question lingers. Why here? Why Earth? Our planet sits in a narrow zone of balance, close enough to the sun for warmth, far enough for stability. Liquid water can flow. The atmosphere shields against radiation but allows light to pass. Gravity holds the oceans without crushing them. Every factor seems tuned to possibility, whether by chance or by design. These conditions created the stage upon which life could appear. We look outward now, searching for echoes of that first miracle. On Mars, ancient riverbeds cut across the red plains, hinting at a watery past. On Europa, beneath its crust of ice, a hidden ocean churns in eternal darkness. On Titan, lakes of methane reflect a hazy orange sky. Everywhere we look, chemistry stirs a reminder that the potential for life may not be unique to us. If we ever find it elsewhere, even a single microbe on another world, it will change everything. It will tell us that the universe does not create life once, but wherever it can. That the spark is not rare, but natural. That we are part of a pattern far greater than ourselves. And yet, even if we never find another living world, the mystery remains no less profound. For life, as we know it, is still a miracle, not because it violates natural law, but because it expresses it so beautifully. From blind chemistry arose sentience, art, laughter, and love. From the movement of atoms came awareness. From the dust of stars came you. Perhaps that is the true answer, not a single cause, but a story. A story written in molecules and time, in oceans and light. The story of matter learning to breathe. As you drift toward rest, imagine that ancient sea, silent, moonlit, endless. Somewhere within it, the first cell divides. Its daughter floats away, carrying the same code, the same fragile fire. And through billions of years, that flame travels forward, through forests and creatures and people, until it arrives here, now, within you still burning. Life began once, long ago, in a world without witnesses. It has never stopped beginning since. 3. Why we sleep. Every night, without fail, we surrender to a quiet ritual that has shaped our species for millions of years. We lie down, close our eyes, and drift into darkness. The body softens. The mind unravels. The world, for a time, disappears. It is one of the strangest behaviors in nature, this daily plunge into vulnerability and stillness. And yet, all living creatures do it in their own way. From the tiny fruit fly to the vast blue whale, sleep seems to be as essential as air, water, and food. But why? Science has spent decades studying this question, and still, it remains partly unanswered. We know what happens when we sleep, but not fully why it must happen at all. Why does consciousness need to dim each night? Why does the mind retreat from awareness, leaving the body unguarded in a world that never stops moving? It seems a dangerous evolutionary habit, and yet every creature that lives and breathes carries the same need to rest, to dream, to enter the realm of sleep. For centuries, philosophers thought of sleep as a passive state, a pause in life's activity, a kind of nightly death. But modern science has revealed something far more intricate. Sleep is not the absence of life. It is one of its most active expressions. While you lie still, your body is at work. Cells repair themselves, muscles heal, the immune system strengthens its defenses. Deep within your skull, neurons fire in orchestrated waves, replaying the day's experiences and weaving them into memory. The heart slows, but the brain hums, a storm of electrical patterns flickering like constellations across the darkened landscape of the mind. Even now, no one can say exactly why we sleep, but we can trace its rhythms. Each night, as darkness falls, the body's internal clock, the circadian rhythm, guides us toward rest. This clock is ancient, synchronized to the turning of the earth and the light of the sun. As night deepens, the brain releases melatonin, a gentle chemical signal that quiets the senses. Heart rate lowers, temperature drops, and consciousness loosens its grip. You fall, slowly, into the layered architecture of sleep. Scientists divide this journey into stages, but in truth it feels more like a tide than a staircase, waves of depth and drift. In the early stage, you hover between wakefulness and dreaming, thoughts dissolving into fragments, muscles twitch, images flicker behind your eyelids. Then comes the deeper descent, slow wave sleep, when the body repairs and restores itself. In this stage, the brain's electrical activity slows to long, rolling rhythms, like the slow breathing of the ocean. Growth hormone surges through the bloodstream, mending tissue and bone. The immune system rebuilds its defenses. The body, in this quiet darkness, heals itself from the wear of living. But the most mysterious stage of all is REM sleep, rapid eye movement, when the mind becomes a storyteller. Here, the brain grows more active than it is while awake. Eyes dart beneath closed lids, muscles fall still, and the dream begins. Entire worlds unfold behind the veil of sleep. People we've never met, places we've never seen, voices that whisper truths we've never heard. The brain blends memory and imagination into a seamless theater of meaning. It rehearses fears, revisits joys, and solves problems in metaphors that vanish by morning. Dreaming is one of the great enigmas of the mind. Some scientists think it's a kind of mental housekeeping, the brain sorting and filing the day's experiences. Others see it as emotional therapy, a safe space where the mind can process pain and confusion without consequence. There are theories that dreams are practice for survival, simulated realities in which ancient instincts test themselves against imagined dangers. And yet, there are also dreams that serve no clear purpose at all. Dreams of impossible colors, forgotten faces, infinite stairways. Perhaps, like art or love, dreaming is something that does not need a reason to exist. When we are deprived of sleep, the world begins to unravel. Memory falters, emotions fray, the mind becomes fragile, its edges blurred. In extreme cases, hallucinations bloom waking dreams that intrude upon reality. Without sleep, even the simplest tasks become monumental. The body aches, reaction time slows, and the immune system falters. It is as if sleep is the thread holding the tapestry of being together. Pull it away, and everything begins to come apart. What is remarkable is how universal this need is. Birds sleep while floating on the wind. Dolphins sleep with half their brains awake, one hemisphere resting while the other keeps watch. Insects enter states of stillness that resemble slumber. Even trees seem to sleep, their leaves drooping and their chemical rhythms changing through the night. The drive to rest is woven into the biology of everything that lives. It is not a luxury, but a law. There are creatures that resist it, sharks that never stop swimming, migratory birds that fly for days without pause. And yet, even they find moments of rest hidden within motion, tiny flickers of renewal, woven into wakefulness. Nature always finds a way to restore what is lost. Sleep, in one form or another, is the body's act of remembering balance. Within the brain, sleep cleanses. During the day, as we think and move and perceive, our neurons generate waste byproducts of metabolism that accumulate in the spaces between cells. When we fall asleep, the brain's hidden plumbing system, called the glymphatic network, opens. Cerebrospinal fluid washes through the neural pathways, flushing out toxins, refreshing the tissues. It is a nightly renewal, a microscopic tide that clears away the debris of consciousness. This, perhaps, is one of sleep's quietest miracles, that it allows the brain to heal itself in silence. Yet still, we ask the question, why must awareness fade for this to happen? Why can't the body repair itself while the mind remains awake? Some suggest that sleep evolved as a form of energy conservation, that for early creatures, stillness meant survival, a way to rest safely while waiting for light. Others believe it is essential for learning, that sleep integrates experience into long-term memory. In experiments, animals deprived of REM sleep struggled to recall tasks they had mastered before. The mind seems to require dreams to understand what it has lived. Sleep is also the great equalizer. It humbles the powerful and soothes the weak. It returns every creature to stillness, dissolving distinctions of species and status. Kings, poets, insects, and whales, all are bound by the same invisible rhythm, the same nightly surrender. It reminds us that we are not machines, but living patterns that must pause to renew their form. Perhaps, beyond biology, sleep serves another purpose, one that cannot be measured. When we close our eyes, the external world falls away, and what remains is the internal landscape, the boundless theater of the mind. In that quiet space, imagination takes the shape of infinity. We meet those we've lost, revisit places that no longer exist, and glimpse possibilities that could never be real in waking life. Sleep allows us to wander through memory and myth, to dissolve into the cosmic rhythm from which all things arise. Every morning, we return from that realm as if reborn. The world sharpens again into edges and light. The mind gathers itself, remembering who and where it is. We stretch, we rise, we begin again. And though the night's journey fades quickly, something of it remains, a trace of clarity, a whisper of renewal, a softness that carries us through the day. No one can say, even now, exactly why we sleep. But perhaps that is not the right question. Perhaps the truth lies not in the function, but in the feeling, in the deep peace that comes when we surrender to rest. In sleep, we are reminded that it is okay to stop striving, to let go of control, to trust that life continues even in stillness. It is the body's way of saying, you have done enough for now. Let the universe hold you for a while. So tonight, as you feel your breath slow and your eyes grow heavy, remember that you are part of this vast rhythm, the same rhythm that has guided life for billions of years, the same rhythm that turns the earth beneath the stars. You are entering the oldest cycle of all, the one that began long before language or thought, when the first living cell learned to pause and begin again. Sleep is not an escape from life. It is the continuation of it, in another form. The mind wanders home, and the body remembers how to heal. The universe closes its eyes through you, and for a little while, everything, absolutely everything, rests. For the nature of time is the quietest of all mysteries. It flows around us constantly, unseen and unstoppable, shaping everything that lives and everything that fades. It stretches between the first spark of the universe and the final breath of a star. It carries rivers toward the sea, ages mountains into dust, and folds every life into a single brief span. Yet, for all its certainty, no one truly knows what time is. We can measure it, divide it into seconds and centuries, but its essence slips through every definition. Einstein once said that time is what keeps everything from happening all at once. It seems simple, almost playful, but the more we examine it, the stranger it becomes. For time is not a constant river, flowing evenly for everyone. It bends, it stretches, it slows and quickens depending on where you are and how you move. High in orbit, clocks tick faster than those on Earth. Near a massive planet, they slow down. Astronauts aging fractions of a second less than those who remain below prove that time is not universal. It is flexible, woven into the same fabric as space, curving wherever gravity whispers its pull. This realization changed everything. Before Einstein, time was imagined as an invisible metronome ticking the same beat for all creation. But relativity revealed that time is part of space itself, inseparable from it, forming the four-dimensional fabric of space-time. Every event, the birth of a star, the fall of a leaf, exists as a point within that fabric, forever fixed in its coordinates. The past and future are not destroyed or waiting. They coexist as parts of the same grand structure. The flow we feel, this sense of moving forward, may be only the way consciousness experiences that eternal geometry. And yet, even knowing this, we still ask the simplest of questions. Why does time move at all? Why do we remember the past, but not the future? The laws of physics make no distinction between directions. On paper, equations work the same whether time flows forward or backward. The universe itself seems indifferent to our sense of before and after. But in life, the arrow of time feels absolute. We see a glass shatter, but never reform. We grow older, not younger. Moments unfold irreversibly, as if the cosmos prefers to move from order to disorder, from memory into forgetting. Scientists call this asymmetry the arrow of entropy, the second law of thermodynamics. In any closed system, energy spreads out, structures decay, and complexity unravels into chaos. It is why stars burn their fuel, why ice melts, why every living thing ages. Entropy defines the forward direction of time, because we can only move toward greater disorder. But even this principle raises deeper questions. Why was the universe's beginning so low in entropy, so perfectly ordered? Why did everything start in such a balanced, improbable state that could allow time to unfold at all? If the cosmos began in chaos, there would be no arrow, no change, no history. Somehow, the universe began already tilted toward becoming. There are moments when we sense the strangeness of time most vividly, when we lose it, or when it slows. During danger, seconds stretch into eternities. During joy, hours vanish like sparks in wind. Time, in these moments, feels elastic, shaped by perception rather than physics. Neuroscientists have discovered that the brain does not experience time uniformly. It measures intervals through patterns of memory, emotion, and attention. The more densely the mind records events, the longer a moment feels. The quieter our experience, the faster it passes. In that way, time is not only a property of the universe, but also a creation of the mind, a rhythm played on the instrument of awareness. Still, beyond our perceptions, there may exist a deeper truth, one where time does not flow at all. Some physicists believe that in the most fundamental equations of reality, time disappears entirely. The universe, in this view, is timeless. Every event simply exists, all at once, in a grand static structure. Our sense of movement through time would then be an illusion, born from memory consciousness sliding along a single path within the whole. We do not travel through time. We awaken to one frame after another, like reading a cosmic film strip. The past has not vanished. The future has not yet arrived. Both already are, waiting in their quiet coordinates of being. Others imagine time as something that emerges only when matter interacts, that in a universe of perfect stillness, without change, time would not exist at all. It would be like music without sound, a dance without motion. Time, then, would not be an independent dimension, but the measure of change itself, the way the universe keeps track of its own evolution. When nothing changes, time ceases to have meaning. Yet, despite our theories, no one can escape time's touch. It shapes us in ways both grand and subtle. Every cell carries its rhythm of decay and renewal. Every breath counts out another measure of existence. The stars above you tonight are both ancient and immediate. Their light set out millions of years ago, yet arriving only now, each photon a messenger from a vanished moment. Looking at the night sky, you are not seeing the present at all, but a museum of the past. Each point of light, a frozen memory traveling through the dark. There is comfort in this. The universe keeps its memories. Nothing that happens ever truly disappears. It only moves out of reach. Somewhere in space-time, the first dawn of the Earth still glows. Somewhere else, your first heartbeat still echoes in its coordinate of the eternal structure. Every moment is preserved, a pearl on the endless thread of being. We, who experience it as flow, are simply following that thread through the illusion of time's motion. Philosophers have long asked whether time itself began or whether it stretches infinitely in both directions. If the Big Bang marked a beginning, what lay before it? Was there a before at all? Some cosmologists propose that time itself was born in that moment, that asking what came before is like asking what lies north of the North Pole. Others imagine a cyclical universe, where time expands and contracts in endless repetition. Big Bang, Big Crunch, rebirth, the cosmic heartbeat, without beginning or end. There is also the possibility that time is not uniform throughout the cosmos. Some theories of quantum gravity suggest that on the smallest scales, time may be granular, made of discrete moments, rather than a continuous flow. Each tick of time could be a fundamental quantum event, imperceptible but real. Between these ticks, perhaps, lies the timeless void from which everything emerges. The universe, then, would not be a smooth stream, but a sequence of flickering instants, much like the frames of a film that our consciousness smooths into motion. And still, we live as if time were simple. We mark calendars, count birthdays, and mourn the years that slip away. Yet time, for all its vastness, is deeply personal. It shapes the rhythm of our hearts, the aging of our faces, the unfolding of our stories. We exist as brief intervals in its endless continuum, flashes of consciousness suspended between what was and what will be. And perhaps that is what makes us human, our awareness of passing, our longing to capture something that cannot be held. Even as you listen now, time is flowing through you, blood pulsing, neurons firing, atoms vibrating in quiet synchrony with the cosmos. Every second you experience is a gift borrowed from the decay of stars, from the expansion of the universe itself. To live is to participate in time's unfolding, to be carried by its current through the unknown. And yet, perhaps there is peace in knowing that the current is not separate from you. You are not drifting through time, you are time. Every heartbeat, every breath, every thought is an expression of it. The universe experiences itself as duration through you, as it once experienced itself as light, as gravity, as the trembling of creation. One day, your own flow of moments will return to silence, just as stars burn out and galaxies fade. But in the language of space-time, that silence is not an ending. It is simply another coordinate, another still frame in the eternal film. Somewhere in that tapestry, you are forever here, forever listening, forever alive in this exact moment. So let time be what it is, vast, unknowable, and tender. Let it pass through you without resistance. Feel the pulse of its rhythm, not as a countdown, but as a heartbeat. For in the end, time may not be a thief at all, but a teacher showing us, through impermanence, the quiet miracle of being here, now, between what was and what will always be. 5. The beginning before the Big Bang, before the first light, before the first atom, before even the faintest vibration of energy. There was, according to everything we know, nothing. No space to hold things, no time to move through, no laws to govern the unseen. And yet, from that nothing, everything was born. The universe unfolded like a flower from a seed that had no form, blooming into stars, galaxies, and minds that could ask how it all began. This is perhaps the oldest and deepest mystery in science. What came before the Big Bang? The Big Bang theory describes the evolution of the universe, not its origin. It tells us that about 13.8 billion years ago, all space, time, matter, and energy existed in a single, unimaginably dense state, a singularity. From that point, space itself began to expand, carrying galaxies outward like seeds in a cosmic wind. As the universe grew, it cooled. Matter condensed into clouds, stars ignited, and worlds began to form. We can trace this story backward with exquisite precision, all the way to the first fractions of a second. But when we reach that singularity, mathematics collapses. Our equations break apart. The very laws of physics cease to make sense. That is where the mystery begins, at the edge of what can be known. What does it mean for time itself to have a beginning? Can there even be a before, when time did not yet exist? The mind struggles with the question, because we are creatures of sequence. Everything we know has a cause and an effect, but the birth of the universe may not fit that pattern at all. Some physicists suggest that asking what happened before the Big Bang is like asking what lies north of the North Pole. Time, they say, was created in that moment, expanding outward alongside space. The universe did not begin in space. It brought space with it. The Big Bang, then, was not an explosion in the void, but an awakening of dimension itself. There was no before, because there was no clock, no flow of moments, only potential waiting to become. Others imagine a more cyclical cosmos, one without true beginning or end. In this view, the universe expands and contracts in an endless rhythm, like breath. The Big Bang would not have been a beginning, but a rebirth, the latest pulse in an infinite heartbeat of creation. When the universe reaches its greatest size, gravity will slowly draw it inward again, compressing matter until another singularity forms, which then bursts outward once more. It is a vision both ancient and elegant, echoed in Hindu cosmology, in Greek philosophy, in the rhythm of the tides and the beating of a heart. Yet modern cosmology hints at something even stranger. Some theories of quantum gravity suggest that before the Big Bang, the universe may have existed in a timeless, quantum state, a kind of cosmic potential without location or sequence. In this quantum foam, space and time themselves flicker into and out of existence. What we call the Big Bang may have been a transition from that timeless sea into the ordered expansion we now inhabit, a crystallization of possibility into structure. Imagine, for a moment, the universe not as a thing, but as an event, a single unfolding process. In its earliest instant, it was smaller than an atom, yet it contained everything that would ever exist. Within trillionths of a second, it inflated exponentially, stretching faster than light, smoothing out irregularities and creating the uniform cosmic fabric we see today. The faint glow of that moment, the cosmic microwave background, still hums across the sky, a whisper of the universe's infancy. But what set that process in motion remains unknown. Some physicists turn to quantum mechanics for clues. According to quantum theory, particles can appear spontaneously out of nothing, as long as they vanish quickly enough to preserve the balance of energy. Perhaps the universe itself emerged in the same way, a fluctuation in the quantum vacuum that did not disappear, but expanded. In this model, the total energy of the universe might be exactly zero, the positive energy of matter perfectly balanced by the negative energy of gravity. Out of nothing, something not by magic, but by mathematics. Yet nothing, in physics, is not truly nothing. Even the vacuum teems with activity, filled with virtual particles that wink in and out of existence. Perhaps then, the universe was never created, but always existed in some form, an eternal sea of potential, where creation and dissolution happen endlessly, without beginning or end. Still others see hints of multiple universes, a vast multiverse, in which countless realities blossom like foam on the surface of an infinite ocean. In this vision, our universe may be one bubble among many, born from a fluctuation in a higher dimensional space. Each bubble would have its own laws of physics, its own constants, perhaps even its own versions of life. The Big Bang, then, would be not the beginning of everything, but simply the moment our bubble detached and began to expand. If this is true, then the ultimate origin may be beyond even the multiverse, a place where possibility itself exists without form, a cosmic field forever spawning new realities. It is a breathtaking thought that creation is not a singular event, but a continuous process. Somewhere, even now, new universes may be blooming, each with its own stars, its own gravity, its own concept of time. And yet, the question remains, why does there exist anything at all? Why is there something rather than nothing? Science can trace the chain of cause and effect, but not the first link. Perhaps there is no first link. Perhaps existence is its own explanation, something that simply is, without needing a reason. Still, the human mind cannot help but reach further, longing to understand the origin of origins. There are those who suggest that consciousness itself may play a role, that the universe exists because it can be observed, that awareness and reality are intertwined. Quantum mechanics hints at this connection, that the act of observation affects what is observed, that the boundary between mind and matter may not be as clear as we think. If so, perhaps the cosmos awakened not into emptiness, but into awareness, and we, its children, are the echo of that awakening. But perhaps the truth is simpler and more profound. Perhaps the question of before has no answer, because there was no before, only this, an unbroken presence stretching beyond the reach of comprehension. Maybe the Big Bang was not the start of time, but the start of change. Before it, everything existed in perfect stillness, a timeless equilibrium waiting for movement. And when that first fluctuation came, when symmetry broke and energy began to flow, the silence became music, and the music became matter, and matter became life. Even now, the echo of that first note continues. The universe expands, stars burn, and minds like yours look back, wondering what began it all. The answer may never be known, yet in seeking it, we participate in the same mystery that birthed us. The universe asks itself where it came from, using human curiosity as its instrument. When you gaze into the night sky, you are seeing the past light that has traveled billions of years to reach your eyes. The further you look, the closer you come to the beginning, until you stand at the edge of time itself. Beyond that, there is only imagination, the quiet realm, before light, before motion, before being. And maybe, in that infinite stillness, everything that could ever exist was already waiting, folded inside a single, silent moment. So, what was there before the Big Bang? Perhaps the simplest answer is the most mysterious of all. There was no before, only potential sleeping, dreaming, becoming. And in one timeless instant, that dream took shape and became reality. The cosmos awoke, and from its awakening came stars, oceans, and hearts that beat in wonder. We are not apart from that beginning. We are its continuation, the universe still unfolding, still asking its first and only question: how did I begin to be? 6. The mystery of dark matter. All across the universe, stars spin through galaxies like luminous leaves caught in invisible wind. They circle their centers far faster than gravity should allow, moving as though some unseen hand holds them together. Yet when astronomers measure the mass of these galaxies, the numbers don't add up. The light we see from stars, gas, and dust accounts for only a small fraction of what should be there. Something else, something invisible, is providing the missing gravity. It has no color, no heat, no reflection, and yet it outweighs all visible matter by a factor of 5. We call it dark matter, and though it binds the cosmos together, we still do not know what it is. The story of dark matter began almost a century ago, with the quiet observation of a curious Swiss astronomer named Fritz Zwicky. In the 1,930 seconds, he studied the Coma cluster, a vast collection of galaxies drifting through space. According to Newton's laws, the galaxies at the edges of the cluster should move slower than those near the center. But when Zwicky measured their motion, he found that they were moving far too fast to be held by the gravity of the visible galaxies alone. They should have flown apart into the void, scattered like dust. Yet they stayed together. Zwicky proposed a daring idea that the cluster was held in place by invisible matter, something that could not be seen but made its presence known through gravity. He called it Dunkel Materia, dark matter. For decades, his idea lingered at the margins of science, unproven and puzzling. But in the 1,970 seconds, another astronomer, Vera Rubin, began mapping the rotation of spiral galaxies. She found that stars on the outer edges orbited just as fast as those near the core, defying all expectations. It was as if an unseen halo surrounded each galaxy, adding extra gravity to keep the stars from flying away. Rubin's observations confirmed what Zwicky had suspected: the universe is filled with invisible mass. And from that moment on, the search for its identity began in earnest. We know dark matter exists because of its gravitational pull, but we have never seen it directly. It does not emit light, absorb it, or interact with it in any detectable way. It passes through stars, planets, and people, as though we are not there. If you held out your hand right now, billions of dark matter particles would pass through it each second, silent and invisible, leaving no trace. Whatever it is, it hides perfectly in plain sight. Scientists have proposed countless possibilities. The most popular candidates are WIMPs, weakly interacting massive particles. These hypothetical particles would have mass, giving them gravity, but would interact only through the weak nuclear force, making them nearly undetectable. If WIMPs exist, they would drift through the universe like a ghostly fog, forming the cosmic scaffolding upon which galaxies build themselves. Another idea points to axions, incredibly light particles that might also fill the universe. If axions exist, they could explain not only dark matter, but some of the deepest symmetries in quantum physics. There are even more exotic proposals: sterile neutrinos, super-heavy relics from the Big Bang, or vast clouds of unseen black holes. But so far, every experiment designed to catch them has found only silence. Deep underground, detectors wait in patient darkness, vast chambers of liquid xenon or crystal, shielded from cosmic rays by mountains of rock. They are designed to sense the faintest tremor of a dark matter particle colliding with an atom. For years, they have recorded only the gentle hum of nothing. Yet scientists continue, undeterred, because the evidence in the sky remains undeniable. Gravitational lensing offers another clue. When light from a distant galaxy passes near a massive object, the curvature of space bends that light, distorting its path. By studying these distortions, astronomers can map the invisible mass around galaxies and clusters. What they find is astonishing webs of dark matter stretching across the universe, forming filaments that connect galaxies into vast cosmic networks. In computer simulations, these filaments appear like a glowing lace of gravity, a skeleton upon which all structure in the cosmos is built. Without dark matter, the universe as we know it would not exist. Even the cosmic microwave background, the faint afterglow of the Big Bang, bears the fingerprint of dark matter. Subtle ripples in that ancient light reveal how matter was distributed when the universe was young. The patterns match perfectly with a universe dominated by something unseen, a hidden mass shaping everything from behind the curtain of physics. And yet, despite all these clues, the true nature of dark matter remains elusive. It behaves like matter, it has mass, it gravitates, but it refuses to interact in any other way. It cannot be captured, burned, or scattered. It does not clump together into stars or planets. It is everywhere and nowhere at once. Some scientists have begun to wonder if dark matter exists at all, or if our understanding of gravity itself needs revision. Perhaps the equations we use to describe motion and mass are incomplete at cosmic scales. Modified gravity theories, such as MOND or TVES, suggest that instead of adding unseen matter, we might need to change how gravity behaves over vast distances. But so far, no alternative has explained all the evidence as elegantly as dark matter does. If dark matter is real, it may form the hidden architecture of everything we see. Galaxies swirl within its embrace. Stars are born in the pockets of its influence, and cosmic evolution follows its invisible patterns. It could be the first and oldest structure in existence, the quiet scaffolding laid down before light itself could travel freely through space. And yet, we are made of something different. Ordinary matter, the atoms that form your body, the Earth, and every star makes up less than 5% of the universe. The rest is dark, matter and dark energy. Unseen and largely unknown. You, everything you have ever touched or loved, are a luminous ripple floating atop an ocean of invisibility. We live surrounded by mystery, our entire history unfolding within the embrace of something we cannot see. What then? Does it mean that most of reality is hidden from us? Perhaps it reminds us that the universe is larger than comprehension, that the visible is only a whisper of the whole. Our telescopes show us light, but light is rare. The true cosmos, the greater part, is made of shadow, and yet that shadow is not emptiness. It is structure. It holds us, even as we fail to grasp it. Imagine standing beneath a clear night sky. Every star you see, every glowing galaxy, floats in a sea of dark matter, drifting through filaments that span millions of light years. Invisible tides of gravity ripple around you. The Earth turns through them, the Sun moves through them, the Milky Way sails through them, and they pass through. You too, silent, weightless, constant. You are within their field always, part of a story that began long before light was born. Perhaps, in the end, dark matter is not a thing, but a sign. A reminder that the universe still keeps its secrets. We have mapped the visible and found that it is not enough. We have weighed the stars and discovered their light cannot tell the whole story. There is always more to the sky, more to existence, more to understanding. And maybe that is what makes this mystery so profound. Dark matter does not simply hide from us. It invites us deeper. It says, in its silence, that reality is richer than our senses allow. It is the universe's quiet way of whispering that we have only begun to see. Someday, we may catch a trace, a faint signal in a detector, a shift in a star's orbit, a particle that proves the invisible is real. Until then, we gaze into the dark and listen for the unseen, for beyond the glow of every star lies a deeper structure of vast and gentle gravity, holding everything together, including you. 7. Dark energy and the expanding universe. When we gaze into the night sky, we are not only looking across space, we are looking through time. The light that touches your eyes tonight began its journey millions or even billions of years ago, crossing the immense distances between galaxies. In that faint shimmer, the universe tells its story, how it was born in fire, how it cooled and gathered into stars, and how those stars drift apart still, carried on a silent current that no one can yet explain. That current is the expansion of the universe, and the force that drives it, invisible and immeasurable, is what we call dark energy. It is everywhere, in every corner of the cosmos, yet no one knows what it truly is. For much of human history, it was assumed that the universe was static, eternal, unmoving, infinite. Even Einstein, whose equations suggested otherwise, added a cosmological constant to keep the universe still. It was an act of caution, perhaps even denial, because the idea of an expanding universe felt too strange, too unstable. But in the 1,920 seconds, the astronomer Edwin Hubble observed that distant galaxies were all moving away from us, their light stretched into longer wavelengths, a phenomenon we now call redshift. The further away a galaxy is, the faster it recedes. The universe, it turned out, was not fixed. It was swelling, stretching, unfolding. Space itself was expanding, carrying galaxies along with it. For decades, scientists believed that this expansion must be slowing down. After all, gravity pulls everything together. Over billions of years, the mutual attraction of all matter should gradually weaken the cosmic expansion, perhaps even reverse it one day, leading to a collapse, a big crunch. But at the close of the 20th century, two teams of astronomers studying distant supernovae, brilliant stellar explosions that serve as cosmic mile markers, discovered something astonishing. The light from those supernovae was dimmer than expected, meaning they were farther away than they should have been. The universe's expansion wasn't slowing down at all. It was speeding up. This single revelation changed everything. Something unknown was countering gravity, pushing the fabric of space apart faster and faster. That force, whatever it is, became known as dark energy. Today, it is estimated to make up nearly 70% of the total energy content of the universe. And yet, like its sibling dark matter, it remains invisible and unexplained. We know dark energy, not by what it is, but by what it does. It stretches the cosmos. It increases the distance between galaxies. It causes the very space between stars to expand, not into anything, but into itself. Imagine dots drawn on a balloon. As the balloon inflates, the dots move apart, not because they are traveling, but because the space beneath them grows. The galaxies of our universe behave in much the same way. But what is the nature of this mysterious force? One idea is that dark energy is the cosmological constant. Einstein once introduced a property of space itself. In this view, the vacuum of space is not empty, but filled with a constant energy density that does not dilute as the universe expands. As new space is created, new energy appears with it, driving expansion ever onward. It is a strange kind of infinity. The more the universe grows, the more energy it contains to make it grow further. Yet when physicists try to calculate how much energy the vacuum should contain, the numbers come out catastrophically wrong off, by a factor of 10 to the power of 120. It is, as some have said, the worst prediction in the history of physics. Clearly, there is something we still do not understand about the way energy and space intertwine. Other theories suggest that dark energy might not be constant at all, but dynamic, a kind of field that, changes over time. Some call it quintessence, after the ancient idea of a fifth element, an unseen essence that fills the heavens. In these models, dark energy may weaken or strengthen as the cosmos evolves, shaping the universe's fate in ways we can barely imagine. We can measure its influence only indirectly, through the way galaxies drift and the cosmic microwave background stretches across the sky. That background, the faint afterglow of the Big Bang, contains subtle imprints of the universe's expansion history. By studying these patterns, scientists can reconstruct how fast the cosmos has grown over time. The results all point to the same conclusion. The expansion is accelerating, and the cause is everywhere, woven into the fabric of existence. What does this mean for the future? If dark energy continues to act as it does now, the universe will keep expanding forever. Galaxies will drift farther apart, stars will exhaust their fuel, and the night sky will slowly darken. Billions of years from now, distant galaxies will vanish beyond the cosmic horizon, their light stretched into invisibility by expansion. The universe will grow colder, emptier, lonelier, a vast silence spreading outward in all directions. Eventually, even atoms may decay, and time itself may lose meaning. It is a haunting vision, the heat death of the cosmos, in which energy becomes too diffuse to sustain change. But perhaps dark energy will not stay constant. If it grows stronger, the expansion could accelerate so violently that it tears apart everything, first galaxies, then stars, then planets, and finally the very atoms that make up matter. This hypothetical end is called the Big Rip, when even space-time itself unravels. If, on the other hand, dark energy weakens or reverses, gravity could regain its hold, halting expansion and pulling everything back together in a final collapse. Between these extremes lies every possible fate: eternal stillness, endless cycles, or a quiet fading into forever. Whatever the outcome, the existence of dark energy reveals something profound about the nature of reality. It tells us that the universe is not merely coasting on the momentum of its birth, it is being driven, actively and continually, by something unseen. That force defines the largest scale of existence, yet it leaves no trace in the small. It governs galaxies, but whispers through atoms without a sound. Perhaps dark energy is not a thing at all, but a reflection of how we measure reality, a clue that our understanding of gravity and quantum mechanics is incomplete. Maybe the equations we use to describe space-time are only approximations of something deeper, something that blends geometry, energy, and time in a way our minds have not yet learned to imagine. There is a quiet poetry in this mystery. The same void that seems empty is what gives the universe its motion. The same nothingness that surrounds us contains the force that shapes everything. Even the space between your hands, between breaths, is alive with this invisible energy, expanding, stretching, part of the same cosmic rhythm that carries galaxies through eternity. Every moment you experience takes place within that expansion. The atoms in your body drift imperceptibly farther apart, following the universe's flow. The light from distant stars reaches you stretched by the same invisible force. You are, in a sense, expanding with it a part of the cosmos that has learned to ask why. And perhaps that is what dark energy truly teaches us, that the universe is not a finished work, but an unfolding process. It continues to grow, to change, to surprise. The same mystery that drives the galaxies outward drives the human spirit to seek, to wonder, to know. We and the universe share this expansion, one of matter and one of mind. Someday, we may find the answer. We may discover the nature of this dark energy, the law that underlies its power. Or perhaps we never will. Perhaps it will remain the universe's secret, the quiet breath of creation that began with the first light and will continue long after the last. For now, we can only stand beneath the stars and feel the great widening of space, the infinite exhale of existence. Everything we see, everything we are, floats within that breath, carried outward, softly, endlessly, into the dark. 8. Quantum entanglement. In the quiet foundation of reality, where particles shimmer and vanish faster than thought, there exists a mystery that unsettles even the calmest equations of physics. It is a phenomenon so strange that Einstein himself called it spooky action at a distance. It defies separation, mocks distance, and whispers that the universe may be more connected than we could ever imagine. This is the riddle of quantum entanglement, a silent bond that unites particles across space and time, linking them so completely that what happens to one instantly shapes the fate of the other, no matter how far apart they are. To understand why entanglement is so astonishing, we must descend into the smallest scale of existence, the quantum realm, where the rules of common sense dissolve. In this microscopic domain, particles behave less like objects and more like possibilities. An electron, for instance, can spin both clockwise and counterclockwise at once, existing in a state of superposition until it is measured. A photon can pass through two slits simultaneously, interfering with itself like a wave of probability. Reality here is not solid or singular. It is fluid, probabilistic, and deeply strange. Entanglement arises when two particles interact in such a way that their quantum states become linked. It's as though their individual stories merge into one. Once entangled, they no longer behave as separate entities. Measure one, and you instantly know the outcome for the other, even if it lies light years away. Their properties, spin, polarization, momentum become mirrors of each other, perfectly correlated, as if connected by an invisible thread through the fabric of the universe. This thread, however, is not a signal, not a communication that travels between them. It is something deeper. The two particles are not exchanging information across space. They simply are not separate in the way we think. They are part of the same quantum state, the same extended system. When you observe one, you collapse not just its wave of possibilities, but the wave that belongs to both. Einstein, with his characteristic caution, could not accept such a thing. To him, the universe was local influences should travel no faster than light, bound by the limits of space-time. Entanglement seemed to break this rule, suggesting instantaneous coordination across vast distances. He proposed that the quantum description was incomplete, that there must be hidden variables, unseen factors that determined outcomes and preserved causality. But experiments later proved him wrong. In the 1960 seconds, the physicist John Bell devised a way to test whether the predictions of quantum mechanics could be explained by hidden variables. His work led to what are now known as Bell's inequalities, mathematical limits that any local classical theory must obey. When these experiments were performed first in the 1980 seconds, and with increasing precision, ever since the results consistently violated those limits, the conclusion was unavoidable. Entanglement is real, and the universe does not respect classical separations. There is no deeper set of hidden instructions guiding the behavior of particles. Reality, at its root, is genuinely non-local. What does that mean? It means that the fundamental fabric of the cosmos is not made of independent pieces, but of relationships, patterns of connection that transcend space itself. When two particles become entangled, they cease to be two. They become one extended entity that happens to express itself in different locations. Their unity is not broken by distance, because distance is not a barrier in the quantum sense. In this way, Entanglement dissolves one of our most basic intuitions, that things exist separately, that here and there are distinct. Some physicists have begun to suspect that this connectedness might be more than a curiosity, that it may be the foundation of everything. Entanglement could be the deep scaffolding from which space-time itself emerges. In certain theories of quantum gravity, space is not a continuous fabric, but a network of entangled information. The geometry of the universe, the curvature that gives rise to gravity, may be woven out of the invisible threads of entanglement. The more two regions of space are entangled, the closer they are in physical reality. When entanglement weakens, space itself stretches apart. In this view, the cosmos is not built from matter, but from relationship, a vast web of correlations through which being itself is defined. At the scale of daily life, entanglement is almost impossible to perceive. The quantum world hides behind the stability of large systems, where countless interactions wash out the fragile coherence that entanglement requires. Yet it is there, quietly maintaining the laws of chemistry, the stability of atoms, the behavior of light. Without quantum superposition and entanglement, the atoms that make up your body could not hold together. The electrons in your cells obey patterns that depend on quantum statistics, a deep order built on the same mystery that connects distant photons. In this sense, entanglement is not rare. It is the hidden foundation of everything you have ever touched. In laboratories, scientists now manipulate entanglement deliberately, weaving it into the circuitry of light and matter. Quantum computers rely on entangled qubits, tiny units of information that can exist in multiple states at once and influence one another instantaneously. By linking qubits through entanglement, these machines can perform calculations that would take classical computers longer than the age of the universe. Entanglement, once dismissed as paradox, has become a tool, a new form of logic, born from the strangeness of the microscopic world. There are even experiments that suggest entanglement can stretch across cosmic distances. Physicists have entangled photons emitted from stars hundreds of light-years apart, confirming that quantum coherence can survive vast expanses of space. The implication is humbling. The universe may be saturated with entanglement, a single connected organism whose parts are never truly separate. And yet, despite our growing mastery of its applications, we still do not understand what entanglement means. It violates every story we have told ourselves about locality, about independence, about cause and effect. It hints that the true architecture of reality might not be built on matter at all, but on information, that what we perceive as physical separation is merely a projection of a deeper, unified field. Some philosophers of physics have begun to suggest that consciousness itself might be entangled, that the act of observation is not passive but participatory, a kind of quantum dialogue between observer and observed. In this interpretation, awareness and matter are not distinct. They are entangled aspects of the same universal process. Whether or not that is true, the thought itself captures something ancient and profound. The intuition that the universe is not divided, that every atom, every beam of light, every thought is part of one continuous whole. It is easy to forget how revolutionary this idea is. For centuries, science has been about separation, dividing the complex into simpler parts, the vast into measurable pieces. Entanglement reverses that direction, suggesting that understanding lies not in isolation, but in relationship. The whole is not made of the parts. The parts are expressions of the whole. When you look at the stars, you are witnessing that connection in action. The photons that enter your eyes were born in the hearts of ancient suns, entangled with particles that may still drift in space. Across impossible distances, their existence is tied to yours, part of a single cosmic equation unfolding in perfect synchrony. You are not merely observing the universe, you are participating in its entangled dance. Perhaps that is why the mystery of entanglement feels so haunting. It reaches beyond physics into something almost spiritual. The recognition that separation is an illusion, that everything that is, once was, and will be, is woven together by invisible harmony. The space between things is not emptiness, but relationship. So, as you lie still beneath the slow turning of the sky, imagine those unseen threads binding atoms, stars, and souls across the dark. Every breath, every heartbeat, every flicker of light is part of that same web. You are not apart from it. You are one of its luminous intersections, connected to everything else that ever was. The universe, through you, feels its own unity, a quiet, infinite entanglement without beginning or end. 9. The nature of gravity. Gravity is the gentlest of all the fundamental forces, and yet it is the one that rules them all. It bends light, sculpts galaxies, and gives rhythm to the orbits of planets. It keeps the oceans faithful to the moon, and it shapes the curve of your body against the earth as you rest. You cannot feel its movement, yet it holds you every moment of your life. And still, after centuries of study, gravity remains a mystery. We can measure it, predict it, even manipulate it to send ships across the void, but we cannot fully explain what it is. It seems so simple at first. Every object with mass attracts every other. The more massive something is, the stronger its pull. The further apart they are, the weaker that pull becomes. This was the revelation of Isaac Newton in the 17th century, that the same invisible force causing an apple to fall was the one guiding the moon around the earth. For the first time, the heavens and the earth were bound by one universal law. Newton's equation described gravity as a force that acts instantly across distance, an unbroken link between all things that possess mass. It was elegant, powerful, and it worked. But even Newton admitted he did not know how it worked. That gravity should be innate, inherent, and essential to matter, he wrote, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it. 2 centuries later, Albert Einstein offered a new vision. Gravity, he proposed, is not a force at all, but a consequence of geometry, the warping of space and time by mass and energy. According to his general theory of relativity, space is not a stage upon which matter acts, but an active participant in the cosmic play. Matter tells space how to curve, and space tells matter how to move. A planet orbits a star not because it is pulled by an invisible string, but because it follows the natural curve of space-time, much like a marble rolling around a stretched fabric. Einstein's vision transformed the universe from a mechanical machine into something fluid, elastic, and alive. Gravity became not an external force, but the shape of reality itself. Time runs slower near massive objects because space and time are entwined in the same fabric, and that fabric is distorted by mass. Light bends around stars because it follows the curved path of space-time. Even the expansion of the universe is shaped by gravity's delicate balance with energy. And yet, for all its precision, general relativity is incomplete. When we peer into the smallest scales of existence, where quantum mechanics reigns, the smooth curvature of space-time dissolves into chaos. At those scales, gravity refuses to fit. The equations that describe the other fundamental forces, electromagnetism, and the strong and weak nuclear interactions, depend on quantum fields, particles, and probabilities. But gravity resists this language. When physicists try to quantize it, infinities spill out of the mathematics like floodwater. Something essential is missing. This failure becomes most glaring inside black holes. According to Einstein's equations, when a massive star collapses under its own weight, it warps space-time so severely that it creates a point of infinite density, a singularity where gravity becomes infinite, and the laws of physics break down. time itself stops. The same paradox appears at the beginning of the universe, when everything that exists was compressed into a single point. At these boundaries, gravity's smooth continuum tears apart, and we are left with silence. Whatever gravity truly is, our current understanding can only circle around it, never touch its heart. Some believe that gravity might not be fundamental at all, but emergent, a property that arises from something deeper. In this view, gravity could be a byproduct of quantum entanglement, a large-scale effect born from the microscopic relationships of particles and information. Space itself might emerge from the web of entangled quantum states, and gravity could be the expression of their collective behavior, much like temperature arises from the motion of countless molecules. If so, then gravity is not a basic force, but a whisper of the universe's hidden order. Others seek to unify gravity with quantum mechanics through new frameworks. String theory proposes that all particles are tiny vibrating strings, and that gravity arises naturally from one of their fundamental modes of vibration. Loop quantum gravity imagines space-time itself as composed of tiny, discrete loops, grains of geometry woven together into a cosmic fabric. Both theories hint at a deeper structure, a quantum geometry beneath smooth space. But evidence remains elusive. For now, these are beautiful possibilities, sketches of truths the universe has not yet confirmed. Gravity's reach, however, is undeniable. It is the architect of the cosmos. It gathers matter into stars and binds stars into galaxies. It is the reason the universe has structure at all. Without gravity, there would be no planets, no sunlight, no warmth. It is both the maker and the destroyer, forging worlds and crushing them back into silence when their time is done. Even light, which moves faster than anything else, cannot escape its grasp once caught within the deep well of a black hole. There, space curves inward so completely that all paths lead toward the center. Time, too, is drawn inward, so that for an outside observer, a falling object appears frozen at the event horizon, its light stretched endlessly toward red. Gravity, more than any other phenomenon, reveals how inseparable time and space truly are. And still, gravity is astonishingly weak. A small magnet can lift a paperclip against the entire pull of the Earth. On the scale of atoms, gravity is almost meaningless compared to the other forces. Yet, because it always attracts and never cancels itself out, it dominates at the largest scales. It shapes galaxies and clusters. It defines the architecture of the observable universe. Weakness, paradoxically, grants it power, for unlike light or charge, gravity never tires. It accumulates, combining endlessly, reaching across trillions of miles to bind everything that exists into one continuous whole. There is a quiet beauty in this. Gravity is the language of connection, the cosmic reminder that nothing exists alone. It is the invisible thread stitching matter to space, time to motion, and you to the planet beneath your feet. It keeps the moon in its rhythm, the oceans in their tides, and the stars in their spiraling grace. It pulls us toward the Earth, but also toward each other, through its deeper metaphoric echo, the sense that we, too, are drawn by unseen forces, kept together by invisible bonds. Perhaps what makes gravity so mysterious is that it feels both external and intimate. It is written into the curves of space-time, yet it also touches your body directly. You feel it in the weight of your hand, the softness of your step, the ache of falling asleep. It does not roar or flash. It whispers, constant and patient. It is the background hum of being. In the vast darkness of the universe, gravity gives everything its place. It tells stars how to dance and galaxies how to grow old. It decides the shape of time, the path of light, and perhaps even the fate of the cosmos itself. Whether it will one day pull everything back into a final collapse or stretch endlessly into stillness remains unknown. But for now, it remains the quiet sculptor of existence, a force that no one can see, yet everyone lives within. To understand gravity fully is to understand not just motion and mass, but relationship and belonging. It is the universe's way of holding itself together, an embrace so gentle and so vast that it contains all that ever was and all that will ever be. As you rest beneath that invisible curve, remember that every falling leaf, every circling planet, every breath drawn against the pull of the earth is part of the same ancient gesture, the cosmos reaching inward, gathering itself, reminding every particle and every person of a single, unspoken truth. Nothing drifts forever. Everything is held. 10. The formation of black holes' singularities. At the heart of every great mystery in the cosmos, there is silence. A silence so deep that even light cannot escape it. This silence is the black hole, the most extreme and elegant consequence of gravity, where matter is crushed beyond recognition, and the known laws of physics surrender. A black hole is not merely an object, it is a mere absence, a place where reality folds in on itself. It is a shadow that bends time, a boundary where the universe stops explaining itself. And at the center of that shadow, hidden beyond reach, lies the singularity, a point so dense, so absolute, that it defies comprehension. To understand the formation of a black hole's singularity, one must begin with the simple act of collapse. Imagine a star, immense, ancient, radiant, burning through the fuel that sustains its warmth. For millions or billions of years, it fights a perfect balance. Outward pressure from fusion pushes against the inward pull of gravity, but all things exhaust themselves, and when the last of the star's fuel is spent, gravity begins to win. The outward breath fades, and the star starts to fall in on itself. If the star is small, it may end as a white dwarf, its matter compressed but stable. If it is heavier, it may become a neutron star, an object so dense that a teaspoon of its material would outweigh mountains. But if the star is massive enough, no force can resist the collapse. The inward fall becomes unstoppable, and the star implodes, compressing its mass into an infinitesimal point. Space and time themselves curve inward toward that center, creating a region from which nothing, not even light, can return. The boundary of no return is called the event horizon, and beyond it lies the singularity, a place where our understanding ends. At the singularity, all the equations that describe space and time break apart. Density becomes infinite, volume becomes zero, and gravity grows without limit. It is a place where the curvature of space-time becomes so steep that the very geometry of the universe is torn. General relativity predicts it, but cannot describe it. Quantum mechanics cannot fit within it. It is a paradox, a point that contains all the matter and energy of a star, but no space in which that matter can exist. We call it a point, but that word is only a placeholder for something we cannot yet imagine. The singularity may not be a point at all, but a region where space and time lose their meaning entirely. Inside it, there may be no before or after, no here or there. The very fabric of existence might dissolve into a form of reality that we have no language for. It is not simply small, it is outside the concept of size. It is not merely dense, it is beyond the concept of density. It is a reminder that the universe, in its deepest places, resists our need for definition. Einstein's theory of general relativity foretold this collapse. But even Einstein himself doubted that such extreme regions could truly exist. He imagined nature would find a way to avoid such infinities. Yet, in 1939, Physicists J. Robert Oppenheimer and Hartland Snyder showed that a sufficiently massive star would indeed collapse indefinitely. No known force could halt it. Nature, indifferent to human intuition, allowed the formation of singularities. Later, the work of Roger Penrose and Stephen Hawking revealed that singularities were not just possible, they were inevitable, given the right conditions. The universe, it seemed, could not help but fold upon itself. And so, black holes became not just theoretical curiosities, but essential features of the cosmos. They are found at the centers of galaxies, weighing millions or billions of times more than our Sunday. They are scattered across the sky as remnants of ancient stars, silent monuments to collapse. Around them, disks of gas spiral inward, glowing from friction as they fall, forming some of the brightest objects in the universe, quasars, powered by darkness. The paradox is poetic, that something invisible could illuminate the cosmos. Still, the singularity remains unseen. The event horizon hides it completely, for light itself cannot escape its curve. What lies within that veil is unknowable, at least for now. But physicists have not stopped trying to understand it. They believe that within the singularity lies the secret to unifying the great pillars of science, general relativity, and quantum mechanics. The first describes the large, the smooth, the gravitational. The second describes the small, the uncertain, the quantum. The singularity is where these two realities collide. Some suspect that singularities are not infinite at all, but that quantum effects soften their edges. According to loop quantum gravity, space-time may be made of discrete, finite loops, and at extreme densities, these loops could resist further collapse, creating a bounce, a rebirth, rather than a void. In such a scenario, what we call a singularity might instead be a bridge, a gateway to another region of the universe, or even to another universe entirely. The interior of a black hole might connect to a new beginning, a mirror image of our own cosmos born from the ashes of another. Others imagine that the singularity may dissolve information, not into nothingness, but into quantum patterns imprinted on the event horizon. This is the heart of the information paradox. According to the laws of quantum mechanics, information cannot be destroyed. But if something falls into a black hole and the singularity erases it, that principle is violated. Hawking suggested that black holes slowly evaporate over time, releasing radiation that carries away energy but not information. Yet if information is lost, the fundamental rules of the universe would fail. The paradox remains unresolved, though many believe the event horizon somehow encodes the information holographically, a cosmic memory stretched over the edge of the void. If this is true, then the singularity may not be a grave, but a library, its knowledge dispersed across the fabric of space itself. What falls in may not be lost, only transformed, translated into the silent geometry of space-time. The idea that everything we see could be a holographic projection, that our universe itself might be the three-dimensional shadow of deeper dimensions, is one of the most haunting possibilities born from the study of black holes. Black holes are paradoxical teachers. They embody both destruction and creation. They erase and yet reveal. They devour stars, but also drive the birth of galaxies. Without the gravitational influence of the supermassive black hole at the heart of the Milky Way, our galaxy might never have taken the shape it has. In their hunger, black holes sculpt the cosmos, and yet, what they are remains deeply unknowable. The singularity sits beyond the horizon, beyond the reach of light and meaning. It is the universe's secret kept within itself, a place where questions cannot follow. Perhaps that is why they fascinate us so deeply. They are mirrors for our own curiosity, for the human need to reach the unreachable. Imagine standing at the edge of one, watching as time slows. From your perspective, an object falling toward the event. Horizon never quite crosses it. Its image freezes, red-shifting into infinity. To you, the fall takes forever, but to the falling object, the moment passes instantly. Time itself behaves differently for each observer. The boundary between now and then blurs. This is gravity at its most profound, not just a force, but a distortion of existence itself. Somewhere in the dark heart of the universe, countless singularities exist, ancient, silent, patient. They are the ultimate expressions of gravity's power, and yet, perhaps, also its humility. For while they hold the greatest densities imaginable, they emit nothing, boast nothing, demand nothing. They simply are stillness within motion, the end within every beginning. Perhaps, one day, we will uncover the truth of what lies beyond that veil. Perhaps we will find that singularities are not dead ends, but doorways, openings through which the universe renews itself. Until then, they remain our most exquisite unknowns, where light itself stops and space folds its hands in prayer. The singularity reminds us of the limit of knowledge, that even in our brilliance, there are boundaries we cannot cross. And yet, it also reminds us that mystery is not emptiness. It is potential, the universe waiting to reveal another layer of itself. Somewhere in that infinite silence, the story continues, written in gravity, written in fire, written in the darkness that binds us all. 11. The consciousness of animals. Across the great tapestry of life, minds bloom in forms we barely recognize. In forests and oceans, in nests, hives, and burrows, awareness flickers behind uncounted eyes. The animal world hums with a hidden intelligence, a chorus of perception and feeling woven through every heartbeat and breath. For centuries, humans believed that consciousness was uniquely ours, that only we were aware, capable of reflection and emotion. But now, slowly and humbly, science is beginning to see that. The light of awareness burns far beyond the boundaries of our own kind. The question is not whether animals are conscious, but how deeply their inner worlds extend and what it means that we still cannot explain our own. When you look into the eyes of another creature, something ancient stirs. It is not logic that recognizes the presence of another mind. It is empathy, intuition, the quiet sense of meeting a fellow traveler in the dark. A dog's expectant gaze, an elephant's grief, the song of a whale echoing across miles of ocean. These moments remind us that consciousness is not confined to words or reason. It is the feeling of being alive, the awareness of experience itself. And yet, science struggles to define what that means, or how it arises. Consciousness itself remains the great mystery of the human mind, and so it is even harder to identify in others. We can measure behavior, observe reactions, and map neural activity, but none of these fully reveal experience. The subjective's silent, what it is like to be another being. Philosophers call this the problem of other minds. You can never truly feel what another experiences. You can only infer it. And yet, evidence of awareness surrounds us everywhere. Consider the octopus, an alien mind that evolved on a separate branch of the tree of life. It has no bones, no voice, and a nervous system distributed through its body, with as many neurons in its arms as in its central brain. And yet it solves puzzles, recognizes individual humans, and can even open jars from the inside. In captivity, they have been known to squirt water at lights to turn them off or escape their tanks under cover of darkness. Their intelligence is fluid, embodied, tactile, a kind of thinking without words. What is it like to be an octopus? To feel thought through touch, to see with the skin. No human can truly know, yet something undeniably aware moves behind those shifting eyes. Or think of elephants, who stand over the bones of their dead and touch them gently, as if remembering. They mourn. They celebrate births. They carry the memories of landscapes across generations. Their social bonds are intricate and emotional. Their intelligence communal rather than solitary. Dolphins, too, exhibit self-awareness, recognizing themselves in mirrors and calling each other by name through signature whistles. They play, they plan, they teach, and they grieve. These behaviors are not mere instinct. They hint at a mind that feels its own being, a consciousness that experiences joy, loss, curiosity, and connection. Even birds, once dismissed as creatures of reflex, now astonish researchers with their cognition. The African grey parrot, named Alex, learned to identify colors, shapes, and materials, and even understood abstract concepts like same and different. Crows fashion tools from twigs and wire, recognizing cause and effect. They hide food and remember not only where but who might have been watching. Such acts require imagination, memory, and the sense of another's perspective, the building blocks of self-awareness. In their small eyes burns a quiet intelligence that rivals our own in complexity, if not in form. Fish navigate intricate social hierarchies. Bees communicate the location of flowers through symbolic dances, and even ants can alter their collective behavior, as if guided by a group mind. The boundaries of consciousness blur, dissolving the human notion of a clear line between sentience and instinct. Life, it seems, thinks in more ways than we have dreamed, yet science remains cautious. To prove consciousness is almost impossible, for it is an inner experience, not a measurable thing. We can observe brain activity, but activity is not awareness. We can identify neural correlates patterns that accompany perception or emotion, but they do not explain how those patterns become subjective experience. This mystery deepens when we consider animals, whose brains are vastly different from ours. A bee's brain contains fewer neurons than a grain of sand contains grains. Yet it navigates the world, learns patterns, and even dreams in its own way. How much awareness resides in such a tiny mind? Is consciousness a threshold, crossed only by complex brains, or is it a spectrum that begins with the simplest spark of sensation and expands toward reflection? Perhaps consciousness is not binary, not something a being either has or lacks, but a continuum that flows through all life. From the simplest organism sensing light to the human mind reflecting on infinity, awareness may be a property of matter itself, a way the universe comes to know its own existence through living form. If so, every creature, every cell, participates in the great unfolding of perception. Consciousness would not be an exception in nature, but its essence. Some neuroscientists suggest that awareness arises wherever information is integrated, where many signals combine into a unified whole. This could mean that consciousness pervades the living world in varying degrees, depending on the complexity of connection. A dog's mind may integrate sensations, emotions, and memories into a single stream of experience, while a jellyfish might feel only the immediate pulse of light and water. Yet even that simplest perception, the feeling of movement, the sense of existence, might be the root of all awareness. Still, for all our scientific tools, the truth remains deeply personal. Anyone who has lived with an animal knows that consciousness cannot be reduced to data. It reveals itself in presence in the gaze that meets yours, with understanding, in the gesture of affection, in the moment of trust. These are not mechanical responses. They are exchanges between minds. They remind us that empathy may be our truest form of recognition, the only language capable of bridging the gap between species. And what of emotions? Do animals feel as we do? Science now says yes. The limbic system, the seat of emotion in the brain, exists in many creatures. Fear, affection, curiosity, and grief are not human inventions. They are ancient evolutionary tools. When a mother elephant loses her calf and refuses to leave its body, she is not acting out of instinct, but out of love and sorrow. When a dog waits for a master who never returns, it is not habit, but hope. Emotion binds consciousness to the world, turning sensation into meaning. Even insects show hints of mood and learning that go beyond mere reflex. Fruit flies deprived of certain experiences exhibit changes in behavior that resemble anxiety. Bees under stress make pessimistic choices, as though expecting negative outcomes. These are not human emotions exactly, but they are emotional nonetheless, chemical and neural signatures of subjective experience. The more we learn, the more humility the evidence demands. We are no longer the lone mirrors of awareness in a mute world. We are one expression of a larger pattern, a continuum of consciousness that hums through the veins of the earth. The forest breathes with it, the ocean sings with it, and every living being participates in its unfolding. Perhaps that is why encounters with animals feel sacred. They remind us that we share this great current of awareness, that the boundary between human and non-human is thinner than we imagine. The same spark that looks out through your eyes shines in theirs, in forms we may never fully understand. And yet, even now, the scientific question remains unanswered. What is consciousness itself? No one knows how matter awakens into experience, how the physical becomes the personal. The mystery of animal consciousness is, in the end, the mystery of our own. To ask what it is like to be an elephant, a bird, or a whale, is to ask what it is like to be anything at all. When you next hear the call of a bird at dawn, or see the slow grace of a whale beneath the waves, pause and remember, something is looking back, not with words, not with reason, but with awareness, the same awareness that glows quietly in you. In that recognition, the world becomes whole again. Every heartbeat echoes the same truth. Life does not merely exist, it knows it exists, and through that knowing, it dreams. 12. The sense of direction in migrating creatures. Every year, as the seasons turn, the living world begins its quiet pilgrimage. Across skies, seas, and forests, billions of animals embark on journeys that span continents and oceans. Monarch butterflies drift from the northern fields of Canada to the forests of central Mexico. Arctic terns cross from pole to pole, chasing endless daylight across the curve of the planet. Salmon find their way back from the open ocean to the exact riverbeds where they were born. Sea turtles, after decades of wandering through featureless seas, return to the very same beaches where they first touched air. These travelers navigate the vastness of the earth without maps, without instruments, without landmarks that endure. And yet they find their way with a precision that defies explanation. The question of how they do it, how they know where to go, when to turn, when to stop, remains one of the most profound mysteries of biology. Migration is one of life's oldest stories, written into the pulse of the planet itself. It is movement as memory, rhythm as survival. For some creatures, it follows the sun. For others, the moon, the stars, the smell of home. In each, there is something deeper than instinct, a form of perception that we barely understand, an inner compass tuned to the invisible structure of the world. Scientists have spent generations trying to decipher this compass. In birds, it is astonishingly precise. A tiny warbler weighing less than an ounce can navigate thousands of miles across continents and open ocean, often alone, often at night. Experiments show that these birds can sense both the position of the sun and the angle of polarized light patterns, invisible to us but inscribed across the sky. Even on cloudy days, they orient themselves correctly, adjusting for the sun's movement as though carrying an internal clock. At night, migratory birds use the stars. In planetarium experiments, when constellations are projected onto domed ceilings, the birds turn and move in the correct migratory direction. When the stars are rotated, their orientation shifts accordingly. They know the patterns of the heavens, not as images but as coordinates. The night sky is their map, and their eyes tuned to wavelengths we cannot see read it like scripture. Yet even these clues do not tell the whole story. Some species migrate at times when both sun and stars are obscured. Some travel across magnetic anomalies, or return home after storms that strip away all landmarks. There must be something else guiding them, a sense beyond sight, beyond sound. This has led to one of the most fascinating discoveries in modern biology, that many animals can sense the magnetic field of the Earth itself. The planet's magnetic field is ancient and constant, generated by the swirling iron core deep within its heart. Invisible lines of force curve from pole to pole, forming a map that never fades. To humans, it is imperceptible. But to birds, fish, turtles, and even insects, it may be as real as color or scent. Studies suggest that birds possess tiny crystals of magnetite, a magnetic mineral embedded in their tissues, perhaps near the beak or the brain. These crystals may act like microscopic compasses, aligning with Earth's magnetic lines and sending information to the nervous system. But there is another possibility, even more astonishing. Some experiments indicate that certain animals might see the magnetic field not as we see light, but as a faint overlay on the world. In birds, a special protein called cryptochrome exists in the retina. When light strikes this molecule, it forms pairs of quantum-entangled electrons that respond differently depending on magnetic orientation. The result could be a visual pattern, a ghostly shading of blue or gold, revealing north and south not through thought, but through direct perception. A robin, soaring through the twilight, may see magnetic fields shimmering across the sky as softly as we see clouds. This blending of biology and physics, of nerve and quantum field, is one of the strangest intersections in science. It suggests that life has evolved not only to sense the tangible, but to tune itself to the hidden geometry of the planet. A migratory bird is, in a very real sense, a living instrument of the Earth's magnetism, a part of the planet, learning its own shape through motion. Sea turtles, too, navigate by this invisible map. When they hatch on moonlit beaches, they imprint on the magnetic signature of that place, a combination of field intensity and inclination unique to every coastline. Decades later, after crossing thousands of miles of ocean, they return to the same magnetic coordinates, even if the landscape has changed. Each beach has its own electromagnetic fingerprint, and the turtles carry it inside them for a lifetime. Salmon may do the same, combining magnetic sensing with chemical memory. As juveniles, they swim downstream to the sea, memorizing the magnetic cues along the way. Years later, guided first by the magnetic field and then by the scent of their home river, they return to spawn. No one taught them the path. It is written into their biology, a harmony between body and planet that operates with wordless precision. Even butterflies, those fragile wanderers, possess this gift. The monarch's journey spans 4 generations, yet each new butterfly somehow knows the route its great-grandparents traveled. They follow the changing angle of sunlight and, perhaps, the magnetic whispers of the earth, navigating not through memory but through inheritance, as if migration itself were a dream passed through DNA. There is beauty in this mystery, but also humility. For all our maps and satellites, for all our compasses and GPS systems, we cannot match the instinctive grace of a bird or a fish finding its way home. Their journeys remind us that intelligence comes in many forms, not all of them conscious or calculated. Some are woven into the fabric of being itself, into the quiet dialogue between organism and environment. And yet, the mechanism remains elusive. No one has fully mapped the magnetic sense. The crystals of magnetite have been found, but not consistently. The proteins that might respond to magnetism work differently in different species. Some experiments succeed, others fail. It is possible that no single mechanism exists, that each creature has evolved its own language with the earth, its own way of reading the invisible. What is clear is that migration depends on something profound, a deep, almost mystical sensitivity to the planet's fields, light, and rhythm. In this way, migration is not just movement, it is communication. The earth speaks through magnetism, and the creatures listen. They hear its message not through thought, but through feeling, through alignment. Their navigation is not calculation, but attunement. It is as if the planet itself is the mind, and the travelers are its dreams, flowing endlessly along the pathways of its magnetic song. There is something deeply poetic about this, that within every migrating animal, the earth has built a memory of itself. The bird in the sky, the turtle in the sea, the insect in the wind, all are parts of the planet's consciousness, carrying fragments of its geometry across space and time. When you watch the geese in autumn, their wings beating southward in perfect formation, you are witnessing this ancient memory at work. They are not simply following instinct, they are following the planet's breath. Every migration is a heartbeat, every return a remembrance. The earth calls, and its creatures answer, tracing invisible lines that have existed for millions of years. Science will one day explain the details, the molecules, the neurons, the quantum entanglements that make this compass possible. But explanation will not diminish wonder. For even when we know how, we will still marvel at the why. Why the universe allows such harmony. Why life is tuned so precisely to its home. Why the simplest creatures seem to carry within them a wisdom as old as the stars. In the end, the mystery of migration reminds us that we, too, are guided by forces we cannot see. Our lives, like theirs, follow unseen currents of gravity, of memory, of longing. The same earth that speaks to the bird and the whale speaks to us, softly, through intuition and awe. We too are migratory beings, forever moving towards something we call home, though we may not yet know its coordinates. And so the great journeys continue across sky, across sea, across the deep time of evolution. The compass points not just north or south, but inward, toward the enduring connection between life and the world that gave it birth. The creatures follow the invisible lines of that connection, not because they know the way, but because they are the way, living echoes of the earth, remembering itself. 13. The source of human emotions. Somewhere within the soft circuitry of the brain, electricity turns into feeling. From these silent patterns of chemistry and charge emerge joy, sorrow, fear, love, anger, awe, the invisible language through which we experience being alive. It is easy to take emotion for granted, to imagine it as a reaction rather than a mystery. Yet when we pause and look closely, the question deepens into wonder. What are emotions, really? Why does a network of neurons and molecules give rise to something as vivid and unquantifiable as happiness, as unbearable as grief? The source of human emotion, though studied endlessly, remains one of science's most elusive frontiers, a place where biology meets the soul, and where knowledge blurs into poetry. Every emotion begins as a pattern of motion inside the body. A sound, a memory, a thought, all trigger cascades of hormones and neurotransmitters that sweep through the nervous system. The heart quickens, muscles tense, the breath shifts. Even before awareness forms, the body is already reacting. Fear tightens the stomach, excitement widens the eyes, sadness softens the shoulders. The body speaks emotion first, the mind follows, weaving narrative around sensation. Yet, if we could look closely enough, we would find that these physical changes are not the emotion itself. They are only the shadow it casts in flesh. The feeling, the raw, subjective essence of emotion arises from somewhere deeper, somewhere that no microscope can yet reach. The earliest roots of emotion are ancient, shared by all creatures that move and survive. Long before thought, before language, emotion evolved as life's first intelligence. A bacterium moves toward nutrients and away from harm, the faint beginnings of attraction and aversion. In more complex animals, the brainstem and limbic system took over that role, transforming simple reflexes into nuanced feelings. Fear warns of danger, desire drives survival. Love, or at least attachment, keeps young alive long enough to learn the world. Emotion, in this evolutionary sense, is not decoration, it is navigation. It teaches life how to stay alive. In humans, the architecture of emotion stretches across the brain. The amygdala detects threat. The hypothalamus regulates bodily response. The hippocampus weaves feeling into memory. The prefrontal cortex interprets and reflects, adding context and meaning. But none of these structures alone can explain what emotion feels like. They describe mechanisms, electrical signals, and chemical flows, but not the experience itself. How does a pulse of dopamine become pleasure? How does an increase in cortisol become fear? How does the simple firing of neurons become the ache of loss? This transformation, from matter to meaning, remains one of the deepest puzzles in neuroscience. Some scientists believe emotion arises from the brain's attempt to predict the world, to anticipate what comes next, and adjust the body accordingly. According to this view, called predictive coding, emotions are not raw impulses, but interpretations, the brain's best guess about what the body's sensations mean. A pounding heart might signal fear, excitement, or anger, depending on context. The emotion, then, is not merely felt, it is constructed. But even this elegant theory cannot explain why those constructions feel so real, why we cry at music, or tremble in awe before beauty, or ache when someone we love is gone. Prediction alone cannot account for the poetry of feeling. Others suggest that emotion is a bridge between the body and the mind, a continuous conversation that allows the two to remain synchronized. The philosopher Antonio Damasio once wrote that emotion is the mind's perception of the body's state. When you feel, you are listening to the orchestra of your own physiology. But even that does not capture the whole truth, because emotion also transcends the body. A memory can bring tears long after the event has passed. A thought can cause the heart to race. Emotions ripple across time, collapsing distance between past and present, imagination and reality. Perhaps that is why emotions feel both primal and transcendent. They belong to biology, yet they speak in the language of meaning. They connect the physical to the metaphysical, turning chemical changes into the stories that define us. Love is not merely oxytocin, it is devotion, sacrifice, memory. Fear is not merely adrenaline, it is the shadow of the unknown. Joy is not merely dopamine, it is gratitude, expansion, the quiet knowledge of being alive. Even when science can trace every molecule involved in emotion, something remains beyond measure the experience of it. Two people may share the same brain chemistry, but the feeling will not be the same. Emotion is shaped by history, culture, language, and belief. It is influenced by memory and expectation. It is colored by who we are and what we've lived. No formula can capture the unique texture of a moment when the heart swells with love or breaks beneath grief. Emotion is both universal and singular, the most shared and most private aspect of life. The study of emotion often leads us back to art and philosophy, where science must stop. Artists have long known what physicists cannot express, that emotion is the soul's way of knowing the world. Music, poetry, and painting all speak to the emotional brain directly, bypassing the intellect. A single note can open a floodgate of feeling that years of reasoning could never unlock. This is not irrationality, but another form of intelligence, one that binds us to the living web of existence. And it is through this emotional intelligence that empathy is born. The ability to feel another's joy or pain is perhaps the most profound achievement of consciousness. In empathy, the boundaries between self and other blur. The same neural circuits that activate when you feel pain light up when you witness another in pain. Emotion allows minds to meet a kind of resonance between inner worlds. It is what makes kindness possible, what gives morality its pulse, what allows love to transcend survival. Yet emotions can also mislead. Fear can distort truth. Anger can cloud reason. Desire can blind judgment. They are both our compass and our storm. Perhaps this duality is what makes them so human. To feel deeply is to risk chaos, but also to touch something sacred. Emotions are the proof that we are not machines, that beneath logic lies something immeasurable, something that connects us to every other living thing. What, then, is their source? Is emotion merely the sum of electrochemical events? Or is it something the universe does through us, the way matter learns to feel itself? Some philosophers have suggested that consciousness and emotion are not emergent properties of matter, but intrinsic to it, that feeling is as fundamental as gravity or charge. In this view, every particle has a trace of subjectivity, and complex organisms like us amplify it into the vast spectrum of human emotion. If that is so, then the heart's sorrow and the atom's vibration may not be so different, both expressions of the universe sensing its own motion. Even if that idea is only metaphor, it carries truth. For in feeling, the universe becomes intimate. Through emotion, the cosmos, once cold and indifferent, becomes capable of compassion, wonder, and love. When you look at the night sky and feel awe, that feeling is the universe marveling at itself. The stars do not. You know they are beautiful, but you do. And in that awareness, their beauty becomes real. Emotion completes creation by giving it meaning. Perhaps that is the true purpose of feeling, to transform existence into experience, to turn matter into meaning. Without emotion, knowledge would be hollow. Without joy, discovery would have no light. Without grief, love would have no depth. Emotion is the soul of understanding, the heartbeat beneath reason, the invisible current that connects mind to world. So, though science continues to trace the circuits and molecules of emotion, perhaps the ultimate answer lies beyond measurement. Perhaps the source of emotion is not something we can find, but something we are. It is the current running through the river of consciousness, shaping how we see, how we love, how we remember. When you feel, you are touching the oldest mystery, the one that made life worth living in the first place. The laughter that rises without reason, the tear that falls without command, the quiet swell of peace that arrives in stillness, all are expressions of the same eternal force. To feel is to be alive, and to be alive is to participate in the universe's ongoing dream of itself. And so, though we may never uncover where emotions begin, we know what they do. They turn the machinery of existence into music. Every beat of the heart, every breath drawn in wonder, every ache, every joy, these are the ways the cosmos feels through us. Emotions are not mere chemistry. They are the pulse of creation made conscious. 14. The puzzle of time. Time moves through us, like breath, unseen yet absolute. We wake into it each morning, drift through its slow current, and surrender to it each night. It measures our lives, but also defines our existence. Everything that has ever been, every birth, every death, every star's ignition and collapse, unfolds within its invisible frame. Yet for all its familiarity, time remains one of the deepest mysteries. In all of science and philosophy, we live by it, depend on it, and yet we cannot truly say what it is. Is it a river that flows from past to future, or a vast landscape in which every moment already exists? Does time move, or do we? When we speak of time, we imagine motion, the ticking of clocks, the swing of pendulums, the orbit of planets. But time itself cannot be seen or touched. It can only be inferred through change. A leaf falling, a wave breaking, a heartbeat. These are not time itself, but its footprints. Without change, time would have no meaning. And yet, without time, change could not occur. They are two sides of one enigma, each giving the other form. Einstein reshaped our understanding of time a century ago when he revealed that it is not absolute. According to his theory of relativity, time is woven together with space into a single fabric space-time, and this fabric bends and stretches in the presence of mass and energy. Clocks run slower near heavy objects and faster in empty space. The passage of time depends on where you are and how fast you move. To a traveler near a black hole, a single minute might contain centuries of the universe's unfolding elsewhere. There is no universal now, only the perspective of the observer. The present, then, is not a universal moment, but a personal one. This relativity of time shatters our everyday intuition. We experience time as constant, flowing uniformly for everyone. But the universe does not agree. It cares little for our clocks or calendars. Time is elastic, expanding and contracting in response to gravity and motion. Even the aging of our bodies, the decay of atoms, the rhythm of life itself, all depend subtly on the curvature of space-time. The world we perceive as stable is quietly stretching and bending around us. If relativity dismantled the idea of absolute time, quantum physics complicated it even further. At the smallest scales, time becomes uncertain, fragmented, less like a flowing stream, and more like a shimmering field of probabilities. Some interpretations suggest that at the quantum level, time may not even exist in the way we experience it, that it emerges only when particles interact, only when relationships form. In that sense, time might not be fundamental, but relational, a product of connection rather than a backdrop to it. This view challenges the very idea of past and future. In certain quantum experiments, the effect seems to influence the cause, as though time were not strictly one way. In the famous delayed choice experiments, the outcome of a measurement can appear to change the behavior of a particle in the past. These results are not easy to interpret, but they suggest that the arrow of time, the sense that it always moves forward, might be less rigid than we think. Still, in our experience, time does have a direction. We remember the past, but not the future. Broken glasses do not reassemble. Heat flows from hot to cold, not the reverse. This one-way progression, called the arrow of time, seems to arise from entropy, the gradual spreading of energy, the increase of disorder in a closed system. The universe began in a state of astonishing order, and since then, entropy has been increasing. It is this imbalance that gives time its direction. The future is simply the direction in which entropy grows. But this only deepens the mystery. Why did the universe begin in such a low entropy state, a condition so improbably ordered that it set the stage for everything that followed? What force or principle arranged the cosmos in this way? Science does not yet know. It is as if time itself began with a whisper of purpose, a bias toward creation and decay, birth and death. Without that initial order, there would be no evolution, no thought, no story. Some physicists imagine that time may not flow at all, that every moment, past and future, exists simultaneously in a vast cosmic structure known as the block universe. In this view, time is not a river carrying us forward. It is a landscape, and consciousness is the traveler. The past does not vanish. It simply lies behind us, and the future already exists ahead. waiting to be experienced. From this perspective, the sense of passage, the feeling that time moves, may be an illusion created by awareness. The universe itself is timeless, but we, as living beings, move through its layers, perceiving them one by one, like pages in a book. If that is true, then perhaps everything that has ever happened or will happen still exists: every laugh, every sorrow, every heartbeat suspended in eternity. The people we have lost, the moments we have forgotten, are still there, preserved in the geometry of space-time. We do not revisit them because we cannot move backward in our perception, but in the grand architecture of the cosmos, nothing is truly gone. It is a strange comfort to imagine that time, rather than erasing, keeps everything. And yet, for all these cosmic perspectives, time also feels deeply personal. It is the medium through which we experience growth, change, and loss. It carries memory, shapes identity, and gives meaning to impermanence. Without time, love would have no urgency, beauty no poignancy, and life no story. Time gives depth to existence by ensuring that nothing lasts forever. We value moments because they end. Biologically, time is written into our rhythms: the beating of the heart, the oscillations of the brain, the rising and setting of the Sunday. Our bodies are clocks tuned to the cycles of the earth. Within our cells, molecular gears turn in patterns of light and darkness, guiding sleep, hunger, attention, and emotion. Even our perception of time shifts with mood. Fear slows it, joy speeds it, sorrow stretches it into stillness. Time, it seems, is not only a property of the universe, but a mirror of the mind. Perhaps that is why time feels both objective and intimate. Why a single second can feel eternal in pain and fleeting in wonder. Time bends not only in space-time but in consciousness. Memory pulls the past into the present. Imagination pulls the future close. The boundaries between was, is, and will be dissolve in the theater of awareness. Some philosophers have suggested that consciousness and time are inseparable, that time exists only because there is someone to perceive it. Without observation, the universe would be static, frozen in infinite potential. Awareness is what makes the flow of time real, just as observation collapses quantum uncertainty into reality. If so, then time is not something that happens to us. It is something we create by being aware. And if time is creation, then perhaps the universe itself is a continuous act of becoming a timeless existence, unfolding itself moment by moment into experience. We live inside that unfolding, each second a bloom in the infinite garden of possibility. We measure it with clocks, but it is older than measurement and deeper than math. No one knows what time truly is. We can describe its effects, measure its passage, and bend it in equations, but we cannot hold it in our hands. It slips through our fingers even as we study it, leaving only memory and motion. Perhaps that is its purpose, to remind us that everything changes, that every heartbeat is both a continuation and a farewell. So we live within time as fish live within water, unaware of the vastness that surrounds us, yet shaped entirely by its currents. And though science may one day explain its structure, time will remain the great mystery that holds all others. Because in the end, to ask what time is to ask what it means to exist, to move, to change, to feel the unfolding of moments that turn nothingness into experience. Time is not only the measure of life, it is life itself, the quiet pulse that carries us from one breath to the next, from starlight to shadow, from birth into everything beyond. 15. The origin of life. Long before thought, before breath, before the soft movement of oceans and clouds, the earth was silent. It was a planet of stone and storm, its skies dense with lightning, its seas thick with chemicals that had no name. And somewhere within that chaos, within the heat and the pressure and the endless tumbling of atoms, something stirred. Molecules that had been drifting aimlessly for billions of years began to organize themselves, to reach toward complexity. From this came the first whisper of life. How it happened, no one truly knows. The origin of life remains one of science's most profound and poetic mysteries, the moment when matter began to awaken. When the universe learned to look back at itself. We know that life exists, and that it requires certain ingredients: water, carbon, energy, and time. But how those simple materials combined to create something capable of growth, replication, and evolution is still unknown. We can describe what life does, but not how it began. The Earth, 4 billion years ago, was young and violent, bombarded by comets, shaped by volcanoes, washed by rains that fell for centuries. It was not yet a world of blue and green, but one of black rock and steaming seas. And yet, within that harshness lay the chemistry of possibility. Some scientists believe life began in the oceans, in deep hydrothermal vents along the seafloor. There, mineral-rich water gushes upward through cracks in the Earth's crust, creating natural chimneys of stone. Within these chimneys, heat and chemistry combine in ways that can form complex organic molecules. The gradients of temperature and pH could have provided the first energy systems, the first reactions that separated inside from outside the beginning of the cell. These vents are cradles of energy and structure. And even today, they host unique ecosystems that thrive without sunlight, powered only by the chemistry of the deep. Perhaps life began in such darkness, not in light, but in heat. Others imagine a different beginning, a primordial soup on the surface, where lightning and ultraviolet light struck mixtures of water, methane, and ammonia, forming amino acids and sugars. In 1953, the Miller-Urey experiment simulated these early conditions, and to the astonishment of science, organic molecules formed spontaneously. From simple gases, life's building blocks emerged. It was as if nature itself wanted to create complexity, as if matter were predisposed toward organization. But the leap from molecules to metabolism, from chemistry to biology, remains the great divide. Amino acids do not live. They do not move, or remember, or replicate. Somewhere between them and the first cell lies the boundary between the inert and the alive. And that boundary has never been crossed again. What, then, defines that moment? Was it the first self-replicating molecule, an RNA strand that copied itself, imperfectly, but persistently, until natural selection took hold? RNA is both a messenger and a catalyst, able to store information and drive chemical reactions. It might have been the bridge between lifeless matter and life as we know it. Yet RNA itself is delicate, and it requires conditions that seem rare. How it arose from simpler molecules is still unknown. Perhaps, before RNA, there were simpler systems, chemical networks that could evolve without genes, patterns of reaction that carried memory in their structure. Perhaps life began not with a molecule, but with a process, a pattern of self-organization that found a way to persist. Others believe life may not have started here at all. The theory of panspermia suggests that the seeds of life could have arrived from elsewhere, carried by meteorites or comets from distant worlds. We have found organic molecules on asteroids and in interstellar clouds, and even amino acids on meteorites that have fallen to Earth. If these materials survived the journey, they could have enriched the young planet's oceans with the raw ingredients of biology. In this view, life did not begin on Earth, but merely continued here, a cosmic traveler finding a new home. But even this idea only pushes the question back further. If not here, then where did it begin? Perhaps the deeper question is not where life began, but why it began at all. What causes matter to seek organization? Why does the universe produce systems that can replicate, adapt, and evolve? Some physicists believe the answer lies in thermodynamics, the tendency of energy to spread out. Life, they suggest, is an efficient way for energy to flow. Living systems increase entropy locally while maintaining order within themselves. In this sense, life may not be an anomaly, but a natural consequence of the universe's laws, an inevitable pattern that emerges whenever energy and matter coexist. Life, then, would be not an accident, but a property of the cosmos as natural as the formation of stars or crystals. Still, there is something uniquely poetic about the transition from chemistry to biology. Molecules do not dream, they do not hunger or fear, but somewhere, in that ancient ocean or volcanic vent, structure gave rise to behavior. The first protocell may have been nothing more than a bubble of lipids enclosing a few reactive molecules, dividing and merging under the push of heat. But in that fragile boundary was the seed of everything to come, the capacity to protect, to adapt, to remember. With time, replication brought variation, variation brought evolution, and evolution, in its endless patience, sculpted the vast cathedral of life that now covers the earth. It is humbling to realize that every cell in your body carries that same ancestral spark. The chemistry that once danced in the ocean's depths still moves within you. The energy that once powered the first reactions still flows through your veins. You are a continuation of that first miracle, a living echo of the planet's awakening. And yet, for all we know about biology, the moment of origin remains hidden. Fossils cannot tell us. Rocks have forgotten. The earliest traces of life on Earth, tiny carbon signatures in ancient stone, are only hints. Perhaps we will never find the first organism, because life did not begin in a single moment, but gradually, over ages, as chemical networks became more complex, as chance and necessity intertwined. Life may not have had a birthplace, but a threshold, a slow crossing from reaction to replication, from chaos to order. Still, even in the absence of proof, there is beauty in the question itself. To search for life's beginning is to search for our own. It connects us to the cosmos in a way no discovery could diminish. Whether life began in the deep ocean or fell from the stars, it means that we are part of something vast and ancient, a continuity of chemistry that stretches back to the birth of the universe. Every atom in our bodies was forged in stars. Every breath we take is a continuation of reactions that began billions of years ago. Life did not appear within the universe. It is one of the ways the universe expresses itself. Perhaps one day we will create life in the laboratory, not by copying nature, but by understanding the principles that make it possible. When that happens, we may finally glimpse the secret that nature has kept since the dawn of time. But even then, the mystery will not end. For the question will remain, why does the universe bother to awaken at all? Why should matter care to live? Maybe life began simply because the universe could no longer contain its own potential. In the stillness of its early ages, something restless stirred a need to feel, to change, to know. And so, in a warm pool or a dark vent, it began to assemble itself, molecule by molecule, dream by dream. The first cell divided, and time itself took a new form, the form of memory, of evolution, of consciousness waiting in the wings. We are the descendants of that first shimmer of order, still unfolding, still questioning. The mystery of life's origin is not behind us. It continues every day within us. Each heartbeat, each breath, is the same story playing a game, the universe learning what it means to be alive. And perhaps that is the final truth, that life never truly began, because it was always there, waiting for the right conditions to awaken. The earth was only its first whisper. We are its voice. 16. The mystery of sleep. Every night, we surrender ourselves to a quiet, familiar darkness. We lie down, close our eyes, and drift beyond the edge of control into dreams, into stillness, into something that feels like both an ending and a renewal. For hours, our awareness dissolves, the world falls away, and the self we cling to each day is gently erased. And yet, when morning comes, we awaken restored, as if the act of forgetting life for a time is what allows us to live again. This is sleep, one of the most ordinary and yet most mysterious experiences we know. For centuries, sleep was seen as a kind of passive state, a shutting down of the brain and body. It was thought to be a nightly death, a pause in the machinery of life. But science has revealed something far more astonishing. During sleep, the brain does not rest. It transforms. Patterns of electrical activity shift and deepen. Memories are replayed and reorganized. Cells repair. Waste is cleared. The body heals. The mind resets. Sleep is not an absence of consciousness, but another form of it, one that science still cannot fully explain. Why do we sleep? Evolution rarely allows for wasted time. To lie unconscious for hours, unable to defend oneself, seems like a terrible disadvantage. And yet, every animal studied so far, from humans to jellyfish to fruit flies, sleeps in some form. It is as essential as food, as unavoidable as death. Even creatures without complex brains show rhythms of rest and activity that resemble our own. Whatever sleep is, it is ancient, older than thought, older than dreaming, older perhaps than nervous systems themselves. When we fall asleep, our awareness gently loosens. The brain passes through stages, from light drowsiness to the slow waves of deep sleep, and then to the vivid theater of dreams known as REM. Each stage serves a different purpose, though their boundaries blur like tides. In deep sleep, the body repairs itself, tissues regenerate, energy stores are replenished. Neurons in the brain fall into slow, synchronized rhythms, like waves rolling through an ocean. It is during this time that growth hormone surges, that immune cells strengthen their defenses, that the heart slows into a patient calm. The body becomes a quiet workshop, rebuilding itself in the dark. REM sleep, in contrast, is a storm of activity. The brain becomes as electrically alive as it is during waking, yet the body remains paralyzed, a necessary safety to keep us from acting out our dreams. It is in this stage that we see and feel worlds born of our own minds. The sleeping brain weaves fragments of memory, imagination, and emotion into moving pictures, often surreal, often profound. The purpose of these dreams is still uncertain. Some believe they are a rehearsal, a way for the mind to test emotions, to process experience, to prepare for the unpredictable future. Others see them as a byproduct of neural maintenance, the brain's natural bystander effect as it strengthens important connections and prunes away the unneeded ones. But whatever dreams may be, they remind us that sleep is not a void. It is a landscape vast, shifting, and deeply human. Inside the sleeping brain, one of its most remarkable tasks unfolds memory. During the day, experience floods our neurons with information, a river too vast to hold all at once. At night, as we sleep, the brain replays and reorganizes this torrent, sorting what to keep and what to let go. Memories are transferred from temporary storage in the hippocampus to more stable networks in the cortex. Emotional experiences are softened, their sharp edges dulled, their meaning integrated. It is as though the mind spends each night rewriting the story of the day, editing it into coherence. Without this nightly act of reflection, our waking selves begin to fray. Indeed, the consequences of losing sleep are profound. Go without it for long enough, and the mind begins to unravel. Concentration falters, emotion destabilizes, hallucinations creep in, the immune system weakens, metabolism falters, judgment clouds. Sleep deprivation is not just tiredness. It is a slow undoing of being. Every function that defines us, memory, creativity, empathy, even consciousness itself, depends on sleep. We do not merely rest in it, we are rebuilt by it. But, for all its necessity, the why of sleep remains elusive. We know what happens when we sleep, but not what compels it. Why must consciousness cycle through this rhythm of disappearance? Some neuroscientists believe that sleep evolved to maintain the brain's efficiency, to clean and reset its circuits, much like a computer defragmenting its memory. During sleep, a system known as the glymphatic network activates flushing waste products from brain cells through channels that only open when we are unconscious. Among the toxins removed is beta amyloid, a protein linked to Alzheimer's disease. Sleep, in this view, is not a luxury, but a cleansing ritual, a nightly detox of the mind. Others see sleep as the brain's way of rebalancing its energy. During waking life, neurons fire constantly, building connections as we learn and experience. This constant activity consumes vast amounts of energy and weakens synapses over time. Sleep allows the brain to downscale, to restore balance, by pruning unnecessary connections and strengthening those that matter most. It is a kind of neural gardening, ensuring that memory and perception remain efficient and clear. Yet, beyond the biological, sleep also carries a spiritual and psychological weight. In myths and religions across cultures, sleep has always been intertwined with death, with rebirth, with the soul's journey into unseen worlds. In dreams, we meet the hidden self, the subconscious that whispers truths we ignore by day. We see symbols, faces, and stories that seem to arise from beyond thought. Perhaps sleep is the bridge between the conscious and the cosmic, the nightly reminder that awareness is not confined to waking life. Even infants dream, their tiny eyes fluttering beneath closed lids, their brains already shaping the architecture of mind. Animals dream too, dogs twitching as they chase imagined prey, cats pawing at invisible threads. The dream state may be a universal expression of the brain's desire to simulate, to imagine, to create. It may be, in some sense, the foundation of consciousness itself. In dreaming, the brain rehearses the act of awareness. It learns to construct reality, first imagined, then real. Some physicists and philosophers have speculated that consciousness and sleep might mirror the universe's own rhythms, cycles of expansion and rest, of creation and dissolution, just as the cosmos may one day fold back into itself. Perhaps each night's sleep is a small echo of that cosmic breathing. When we close our eyes, we return to the stillness from which we came. When we awaken, we emerge again, renewed, a small reenactment of the universe's endless rhythm of becoming. What makes sleep so mysterious is that we enter it every night and yet do not remember it. It claims a third of our lives, and we pass through it as through a gate that forgets its travelers. We know only the dreams that survive the crossing. The rest is silence. Perhaps this forgetting is not a flaw, but a mercy, a way of protecting us from the strangeness of our own minds. In sleep, the boundary between self and world dissolves, and we touch something beyond individuality. To remember it too clearly might unmoor us from waking life. Still, sleep is not just absence or escape. It is creation, renewal, connection. It is the time when the mind meets itself in secret. It allows the brain to weave coherence out of chaos, to heal, to make meaning. It is both biological necessity and metaphysical act, a quiet merging with something larger than ourselves. When you lie down tonight, you will once again cross that threshold. You will leave behind identity, language, and thought. Your body will enter a choreography older than humanity, older than the earth itself, a pattern written into the rhythm of all life. You will dream, though you may not remember. You will heal, though you will not feel it. You will die to the day so that you may awaken again. And when morning comes, when you rise from that quiet ocean, remember this: sleep is not a departure from life, but its deepest form. It is the pause that sustains the song, the silence that allows meaning to exist. Every dream, every breath, every night's surrender is the universe teaching you how to begin again. 17. The mystery of dreams. When we close our eyes and drift into sleep, the waking world dissolves. The walls of the room vanish. Time loses its grip, and reality rearranges itself into something both intimate and impossible. In that private darkness, we walk through places that have never existed, speak with those long gone, fly without wings, fall without pain, and wake with tears we do not understand. Dreams, those flickering worlds within us, have been our most faithful companions since the dawn of consciousness. Yet, for all our science and philosophy, we still do not know what they truly are. Every night, as the brain descends into sleep, it travels through cycles from deep, slow waves of rest to the bright, chaotic storm of REM. It is during REM sleep, when the body is paralyzed, but the brain is alive with activity, that most vivid dreaming occurs. The eyes dart beneath the lids, mirroring unseen motion. The heart flutters, the breath quickens, and the mind ignites into imagery and emotion. The brain's visual and emotional centers light up, while the regions responsible for logic and self-control fall silent. The result is a theater without boundaries, a stage where reason sleeps and imagination takes command. Why do we dream? The question has haunted thinkers for as long as humans have wondered about themselves. To the ancients, dreams were messages from the divine oracles, prophecies, warnings carried from gods to mortals. To Freud, they were the disguised language of desire, expressions of hidden wishes and repressed memories. To Jung, they were symbols from the collective unconscious, the shared well of myth and meaning that binds all humanity. Science, however, sees them differently, as a function of the brain's nightly maintenance, a kind of cognitive rehearsal or emotional regulation. And yet, none of these explanations feels complete. Dreams seem too vast, too meaningful, too strange to fit neatly into any one definition. One prevailing theory suggests that dreams help us process emotion. During the day, our experiences fill the mind with unresolved tension, fears, hopes, disappointments, desires. At night, as we sleep, the brain replays these emotional patterns, reshaping them into stories that allow us to release and integrate them. The amygdala, the center of emotion, is highly active in REM sleep, while stress hormones like norepinephrine are reduced. It is as if the mind replays pain and joy in a safe theater, free of real consequence. A nightmare might then be the mind's attempt to confront fear in symbolic form, a rehearsal for waking life's dangers. Another view sees dreaming as the brain's way of weaving memory into meaning. As neurons replay the day's events, fragments of thought combine in unexpected ways, producing surreal narratives. In this sense, dreams are a byproduct of learning, the byproduct of the brain's attempt to find patterns and associations. When we dream, we may be strengthening the very networks that help us make sense of experience. This might explain why dreams often borrow details from recent events and combine them with the distant past. Memory is fluid during dreaming. It follows emotional logic rather than chronology. Yet the emotional and mnemonic theories, for all their insight, cannot explain the exquisite creativity of dreams, their ability to invent entirely new worlds. In dreams, the mind does not simply replay life, it transforms it. We can experience music that does not exist, landscapes we have never seen, and conversations that seem wiser than our waking thoughts. Some artists and inventors have drawn inspiration from dreams, Mary Shelley's Frankenstein, Paul McCartney's melody for yesterday, and the periodic table's structure all came, in part, from visions born in sleep. Perhaps the dreaming brain is a creative laboratory, a space where consciousness experiments without the limits of reality. And still, there are mysteries within mysteries. Why do some dreams recur, repeating the same images or themes across years or even lifetimes? Why do some vanish at waking, while others linger with the vividness of truth? The memory of dreams fades quickly because the neurotransmitters that encode waking memory, serotonin and norepinephrine, are largely absent in REM sleep. Dreams are written in ink that evaporates at sunrise. Yet, the most powerful ones leave impressions deeper than language, shaping mood and intuition long after their details are forgotten. Lucid dreams add another layer to the mystery moments when the dreamer becomes aware within the dream. In lucid dreaming, the dreamer realizes they are asleep and can sometimes influence the dream's course, flying through imagined skies or walking across impossible landscapes with deliberate control. This phenomenon raises profound questions about consciousness itself. If we can be aware while dreaming, if we can recognize illusion within illusion, then what separates waking life from the dream? Perhaps both are states of mind, differing only in degree, not in kind. Neuroscientists have tried to map lucid dreaming by observing brain activity during REM. They find that certain regions associated with self-awareness, particularly in the prefrontal cortex, reactivate during lucidity. It is as if consciousness, normally dimmed in dreams, flickers back to life for a moment. This hybrid state, both asleep and awake, challenges our understanding of awareness. It suggests that consciousness is not binary, but fluid, capable of existing on a spectrum between worlds. Dreams also bridge the boundary between mind and mystery. Many cultures have treated them as doors to the Pan, spirit world, places where ancestors or deities can speak. While science does not affirm such beliefs, it does acknowledge that dreams connect deeply to the unconscious, the reservoir of the self that influences thoughts, behaviors, and desires beyond awareness. Whether mystical or psychological, dreams remind us that the mind extends far below its visible surface, that beneath every thought lies an ocean of images and feelings that shape who we are. In modern times, we often dismiss dreams as trivial, but to do so is to ignore one of the most profound aspects of being alive. For when we dream, we are both creator and participant, both author and reader of our own stories. The dream world reveals the brain's remarkable ability to simulate reality, to generate experience from nothing but itself. It may be that the capacity to dream was an evolutionary rehearsal for imagination, a way for early humans to anticipate, plan, and empathize. In this view, dreaming gave rise to the very qualities that make us human: creativity, foresight, and meaning. But perhaps there is another way to see dreams, not as tools, not as mechanisms, but as expressions of existence itself. When the universe evolved life, it gained the ability to reflect. When life evolved consciousness, it gained the ability to feel. And when consciousness evolved dreaming, it gained the ability to create worlds within itself. A dream is the cosmos turning inward, imagining itself again and again. Even now, as we study the electrical storms of REM sleep and map the brain's secret patterns, the essence of dreams eludes capture. They are made of both matter and mystery, electrical signals dressed in emotion, fragments of memory shaped by soul. Perhaps science will one day explain every mechanism of dreaming, but its meaning will always be more than explanation can hold. For dreams are not merely functions of the brain, they are the poetry of the self, the nightly reminder that within every one of us lies a universe vast enough to contain all others. And so, when you next awaken from a dream half lost between sleep and morning pause, before dismissing it, Feel the lingering emotion, the fading scenery, the echo of something ineffable. That fleeting sensation is a message not from elsewhere, but from within, a reflection of your deepest nature. The dream is you, seeing yourself through the eyes of infinity. We may never fully understand dreams, but perhaps we are not meant to. They exist to remind us that consciousness, no matter how deeply studied, will always hold mystery at its core. For even in sleep, the mind continues its quiet miracle, transforming silence into story, thought into vision, and life into something luminous and strange. In the vastness of night, when the stars are silent and the body rests, the universe dreams through you. 18. The mystery of death. There comes a moment in every life when breath grows shallow, when time folds quietly around the body, and the pulse that once carried us through the world begins to fade. It is the one certainty that shadows every birth, the ending that waits in silence, patient and unhurried. Death is both inevitable and incomprehensible. We know it will come, and yet no amount of knowledge prepares us for what it means. Science can describe the processes, the cessation of function, the fading of neurons, the cooling of flesh, but beyond those measurable facts lies something vast and unknowable. For all our instruments, all our theories, we still cannot say what happens to awareness when the body can no longer hold it. We do not know where consciousness goes, or if it goes anywhere at all. Death remains the final frontier, the oldest and deepest mystery of existence. Every living thing is born with an expiration written into its cells. The same chemistry that allows life to grow also ensures its eventual decay. Cells divide, age, and die. Organs wear down, DNA frays, and the intricate symphony of life slowly loses rhythm. Some animals resist it longer than others, jellyfish that revert to youth, bacteria that divide indefinitely, but even they are bound by cycles of renewal and loss. On a cosmic scale, even stars die. Death, it seems, is not an interruption of life, but its twin, a necessary part of the pattern that allows new forms to emerge. For most of human history, death was not a scientific question, but a spiritual one. It was seen as a passage, a journey from the physical to the eternal, from the seen to the unseen. Ancient cultures built monuments to guide the soul. The pyramids of Egypt, the burial mounds of China, the stone circles of Europe. Death was treated as transformation, not annihilation. Even now, in an age ruled by reason, that intuition persists. Something in us resists the idea that consciousness can simply vanish, that the rich inner world of thought and feeling could end as abruptly as a flame snuffed in wind. Science, however, sees death as the end of biological function. When the heart stops beating, oxygen ceases to flow to the brain. Within minutes, neurons begin to die, and the network that gives rise to consciousness collapses. Memory fragments, identity dissolves, and the intricate coordination that defines life falls into stillness. From this perspective, death is not a transition but a conclusion, the irreversible breakdown of complexity. And yet, even within this mechanistic view, strange phenomena persist. In the moments surrounding death, some people report vivid experiences, the sensation of leaving the body, moving through tunnels of light, encountering loved ones long gone. These near-death experiences are strikingly consistent across cultures and centuries. Neuroscience has proposed explanations, surges of activity in the dying brain, the release of endorphins, the effects of oxygen deprivation, but none fully account for the depth and coherence of these visions. To those who have lived them, they feel profoundly real, not hallucinations, but revelations. Perhaps they are the brain's way of easing the passage, or perhaps they hint at something more, a continuity we cannot yet perceive. Even after clinical death, consciousness lingers longer than we once believed. Recent studies using electroencephalography have recorded bursts of organized brain activity for up to a minute after the heart has stopped. These final surges may represent the brain's last orchestration, a closing act of neural symmetry as it shuts down. In animal studies, such activity appears more structured than random, as though the brain, even in its dying, is still performing the choreography of life. We do not know what this activity means, or if it corresponds to awareness, but it reminds us that the boundary between life and death may not be as abrupt as it seems. Some researchers have begun to explore what might be called the physics of consciousness, the idea that awareness could be more fundamental than the brain itself, perhaps a property woven into the universe like space or energy. In such a view, death might not destroy consciousness, but change its form, the way matter transforms into energy and energy into matter. This is speculation, of course, but it resonates with ancient intuition that death is not the end, but a metamorphosis. And yet, for all our yearning for continuation, there is beauty even in finality. Without death, life could not evolve. Without endings, nothing could renew. Every generation inherits the world from the passing of the one before it. Forests depend on decay as much as growth. Stars forge new elements only in their dying. On every scale, life feeds on death and death feeds life. The two are inseparable two breaths of the same eternal rhythm. The human heart, however, does not think in cosmic terms. It feels the absence of the ones it loves. It measures death not by its necessity but by its cruelty. When someone we love dies, the world feels ruptured, smaller, quieter. Grief is the mind's protest against impermanence, its refusal to accept that what was once so vivid could simply cease. Yet grief is also proof of connection. We grieve because we love, and to love is to accept that loss is woven into the design of existence. Perhaps then, death is not a punishment, but a gift that gives meaning to life. It creates urgency, focus, tenderness. Knowing that our days are numbered makes each one luminous. The fleeting nature of life teaches us to cherish what we have, to hold each moment as sacred. Immortality, were it possible, might rob existence of its sweetness, its sense of wonder. The flower's beauty lies in its fragility. The dawn's brilliance lies in its passing. Still, the question remains, what, if anything, becomes of the self when the body fails? Science cannot answer this, for its instruments are tuned to matter, not to mystery. Consciousness is not yet measurable in physical terms, and so its fate remains unknowable. Some see death as a return to the same stillness from which life arose, the eternal silence before birth, resumed at the end. Others sense a continuity, a presence that endures, unbound by form. Perhaps both are true. Perhaps death is not the opposite of life, but its completion, the moment when individuality dissolves back into the greater whole. There is a calm in this possibility that everything we are, every thought and heartbeat, is part of a larger pattern that never truly ends. Just as a wave rises from the ocean, moves for a time, and then falls back into it, so too might we return to the source from which we came. The wave disappears, but the water remains. Its essence is not lost, only transformed. When you stand beneath the night sky and look at the stars, remember that their light is old, that some of those stars have already died, their radiance still crossing the void to reach your eyes. Death and light travel together in this universe. What you see when you look up is not the absence of things, but their persistence. In that light, death is not an erasure, but a continuation, the echo of something that once was, still moving through space, still illuminating the dark. Perhaps that is what we are too. Echoes of something vast and enduring, briefly taking form, briefly speaking, briefly remembering ourselves before returning to silence? If so, then death is not to be feared. It is the final act of belonging, the return to what has always held us. One day, each of us will take that final breath. The body will grow still. The mind will release its grip on the story. But perhaps, in that moment, there will be no terror, only recognition. The same silence that waits at the end is the one that was there before the beginning. It is the stillness from which all things arise and to which all things return. Until then, we live not in defiance of death, but in harmony with it. We build, love, remember, and hope. We look into the faces of those we cherish, knowing that time is short and that this brevity makes everything precious. And when the moment comes to let go, perhaps we will find, as countless others have before us, that death is not darkness, but the quiet light at the end of waking, the soft merging of what was once separate back into the infinite whole. 19. The mystery of the mind-body connection. Within you, there is a constant conversation taking place, a dialogue between matter and awareness, between the tangible and the invisible. Your body and your mind, though often spoken of as separate, are bound by a bond so intimate that no thought arises without a physical echo. No movement occurs without an accompanying flicker of consciousness. The heart quickens at fear, the breath slows at peace. A single memory can cause the skin to flush or the eyes to fill with tears. Somehow, what is immaterial emotion, thought, will, can shape the material body. And what is physical hormones, neurotransmitters, heartbeat can sculpt the landscape of the mind. This interplay, this dance between biology and awareness, is one of science's most profound and unsolved mysteries, the mind-body connection. The human body is a universe of activity. Each second, trillions of cells exchange signals, share energy, and maintain the fragile balance of life. The nervous system carries electrical messages along fibers so thin they could be mistaken for threads of light. The brain receives these signals and weaves them into perception, sound, color, texture, temperature. But the mind does something more. It takes this raw data and transforms it into experience. The pattern of light becomes beauty. The vibration of air becomes music. The pressure of another hand becomes love. And still, we cannot say how or why this happens. Where does sensation become meaning? At what point does chemistry become self? Philosophers have wrestled with this question for millennia. René Descartes once declared that the mind and body were separate substances, one material, one immaterial, linked somehow through the pineal gland deep in the brain. His view, called dualism, shaped Western thought for centuries. But modern neuroscience suggests that the mind is not separate from the body at all. It is an emergent property of it, consciousness, arising from the coordinated dance of countless neurons. Yet even this view leaves something unsolved. If the mind is merely the activity of the brain, how does that activity create the feeling of awareness, the vivid, first-person experience of being alive? This is the hard problem of consciousness, and it remains unsolved. The body affects the mind in ways we can measure, yet cannot always explain. Stress, for instance, begins as an emotional response but quickly becomes physical. The adrenal glands release cortisol and adrenaline. The heart pounds. The immune system shifts. The muscles tighten. Chronic stress can cause disease, yet it originates in thought, an interpretation, a belief, an anticipation of threat. The reverse is also true. The body influences the mind. Exercise can lift mood. Breathing can calm anxiety. Diet can alter emotion. When we move, we change our chemistry. When chemistry changes, we alter our perception. It is a loop without a clear beginning, a circle in which cause and effect blur into one. Consider the placebo effect, one of the most striking proofs of this unity. When a patient believes a treatment will help, the body often responds as if it has. Sugar pills relieve pain. Saline injections reduce inflammation. Fake surgeries sometimes produce real healing. Placebo responses are not imaginary. They are measurable physiological changes. The mind, through expectation and belief, triggers cascades of neurotransmitters, endorphins, and immune responses that mimic the effects of real medicine. This is not deception. It is biology obeying belief. And yet, we do not know exactly how belief does this. It is as if thought itself has a kind of gravity, capable of shaping matter from within. Meditation offers another glimpse of this connection. When the mind turns inward, focusing on breath or stillness, measurable changes occur in the body. Heart rate slows, blood pressure drops, immune function improves. Over time, the very structure of the brain changes. Regions associated with compassion, attention, and emotion regulation grow denser. What begins as an act of awareness becomes a transformation of tissue. The line between mental and physical blurs until it disappears. Emotion is another bridge between mind and body. We speak of having a broken heart or butterflies in the stomach, not as metaphors, but as reflections of truth. Emotional states are embodied. They live in muscle tension, posture, and breath. Fear contracts the body. Joy expands it. Grief is heavy. Love is warm. Each feeling is both a mental and physical event, inseparable from the body that hosts it. Studies show that even posture can shape mood, that standing tall can increase confidence, that smiling can lift sadness. The body does not simply respond to the mind, it participates in it. Neuroscience continues to map the connections. The vagus nerve, winding from brain to heart to gut, carries signals that link thought and physiology. The gut, often called the second brain, contains over 100 million neurons and produces neurotransmitters like serotonin and dopamine. Changes in gut bacteria can influence mood and behavior, and emotional stress can alter digestion. This bidirectional communication, the gut-brain axis, shows that consciousness is not confined to the skull. It is distributed throughout the body, a network of awareness embedded in flesh. Still, no amount of anatomy can capture the subjective side of this union. Pain, for example, is not just a physical signal, but an interpretation. Two people can suffer the same injury, yet experience different levels of pain, depending on expectation, attention, and emotion. Place your hand in ice water while thinking of someone you love, and it will hurt less. The body's perception changes under the influence of thought. Consciousness, it seems, is not a passenger riding in the vehicle of the body. It is part of the engine itself. Some traditions have long understood this integration intuitively. In Eastern philosophy, the mind and body are not separate, but aspects of the same energy, the movement of life expressing itself in different forms. Practices like yoga, tai chi, and mindfulness cultivate harmony between the two, dissolving the illusion of separation. Modern science, with its growing understanding of psychosomatic medicine, is slowly rediscovering what these ancient systems already knew, that the health of the body and the peace of the mind are reflections of one another. Even language reveals the unity. We say, a thought is hard to digest, a person gets under our skin, a problem weighs on us. These phrases are not poetry alone. They are descriptions of real phenomena. The body absorbs emotion, carries memory, and expresses truth when words fail. Trauma, for example, often lodges itself in the body. Muscles remember what the mind tries to forget. Healing, then, must occur in both, through movement, awareness, and compassion. Perhaps the greatest mystery of the mind-body connection lies not in its biology, but in its meaning. If consciousness can influence matter, and matter can shape consciousness, then the boundary between the physical and the mental is not fixed. The body may be the mind's expression in 3 dimensions, the visible face of something deeper. When you feel love, fear, gratitude, or awe, those experiences are not trapped inside the skull. They ripple outward, affecting heart rhythm, breath, hormones, even the electromagnetic field of the heart itself, which can be measured several feet away. Awareness, it seems, radiates through every cell and beyond the personal. Perhaps this connection extends further beyond individual bodies, into the collective field of life itself. The empathy we feel when we witness another's pain, the synchronization of heartbeats in those who share an emotional moment, the subtle resonance between people and environments. These might all be hints that consciousness and matter are not separate at all, but part of one continuous fabric of existence. No matter how we explain it, the truth is undeniable. To care for the mind is to care for the body, and to care for the body is to care for the mind. They are not 2 things, but one, 2 reflections of the same luminous whole. When the mind quiets, the body heals. When the body relaxes, the mind clears. This reciprocity is not coincidence. It is the essence of what it means to be alive. Perhaps one day, science will find the precise mechanism by which thought becomes flesh and feeling becomes form. But even then, the mystery will remain not in the mechanism, but in the miracle. The miracle that awareness can touch matter, that intention can shape biology, that something invisible can take root in muscle and bone. The mind and body are not separate realms. They are the same ocean seen from different shores, waves of matter and consciousness, rising and falling in harmony, remembering that they were never apart. 20. The edge of the unknown. There comes a point, in every field of human thought, where knowledge thins like mist and silence begins. It is the frontier where certainty dissolves and wonder takes its place, the edge of the unknown. We have mapped continents, decoded genomes, and touched the outer planets. We have built instruments that can see the birth of galaxies and microscopes that can glimpse the machinery of life. Yet for all our understanding, we remain surrounded by mysteries that defy explanation. The more we learn, the more the horizon recedes, reminding us that the universe is not a riddle to be solved, but a poem to be lived. From the beginning, science has been our way of asking the universe to reveal itself. Each discovery, fire, gravity, the atom, evolution seemed at first to promise finality, as if the great questions would soon be answered. And yet, with every answer came more questions. We split the atom and found a storm of particles, each smaller and stranger than the last. We mapped the cosmos and found dark matter and dark energy, invisible forces that make up most of existence and yet remain beyond our comprehension. We studied the brain and found consciousness, an awareness that no equation can fully describe. It is as though knowledge, by its very nature, opens new doors faster than it closes old ones. The unknown is not an absence of truth. It is the space that truth grows within. It is the fertile darkness from which discovery emerges. Without it, science would have no purpose, and imagination no direction. Yet the unknown also humbles us. It reminds us that even our most elegant theories are temporary scaffolds, built to reach for something that can never be fully contained. The universe is too vast, too intricate, too alive to be enclosed by human thought. It changes as we observe it, reshaping itself under the gaze of our curiosity. Consider the smallest scales of existence, the quantum world, where certainty breaks down and possibility reigns. Here, particles exist not as fixed entities, but as probabilities, flickering between being and non-being, guided by laws that defy classical logic. Observation itself seems to alter reality, as though consciousness participates in the unfolding of matter. This is not mysticism but physics, and yet it carries an echo of mystery older than science itself. How can something exist as both wave and particle, as both here and everywhere at once? What does it mean that the act of measurement creates the outcome? The deeper we look, the more reality behaves like a dream, coherent, measurable, yet profoundly elusive. At the other end of scale, the cosmos stretches into silence. We gaze through telescopes at light that has traveled for billions of years, light from stars that no longer exist. And even as we map the structure of galaxies, we find that most of the universe is invisible. Dark matter, unseen, untouchable, outweighs all the luminous matter by a factor of 5. Dark energy, even stranger, drives the universe's expansion faster with time, as though space itself is alive with hidden force. We can measure its effect, yet we do not know what it is. The cosmos, it seems, is built not from what we see, but from what we cannot. The unknown also lives within us. The human mind, for all its self-awareness, remains largely uncharted. We do not yet understand how thought arises, how memory forms, how the electric whisper of neurons becomes the feeling of love, grief, or wonder. Consciousness is both the instrument by which we explore and the mystery we cannot explain. We peer into the brain and see activity networks and chemical flows, but not the subjective experience itself. It is as if awareness hides behind a veil, showing us its effects, but never its essence. Perhaps the unknown within is as deep as the unknown beyond. Even time, that steady pulse by which we measure life, turns strange at the edges of understanding. In relativity, time bends and slows. In quantum theory, it may not even exist as we perceive it. At the Planck scale, the smallest possible measure of existence, the very fabric of space and time trembles, dissolving into something beyond geometry. There, our equations fail, and reality itself seems to hesitate between being and becoming. What lies beyond that hesitation is the unknown, not empty, but full of possibility. And yet, the unknown is not an enemy of science. It is its heart. Every great discovery begins with a question, with the courage to admit ignorance. To stand before the mystery of the universe is not to be defeated, but to be awakened. There is humility in not knowing, and in that humility lies freedom. When we accept that the unknown is infinite, we begin to see that knowledge itself is a kind of dialogue, a conversation between what is revealed and what remains hidden. Throughout history, we have tried to define the boundaries of what can be known, but those boundaries have never held. Once we thought the Earth was the center of creation. Now we know we are one planet among billions. Once we believed the atom was indivisible. Now we see it as a cosmos in miniature. Once we thought life was unique to Earth. Now we search the stars for reflections of ourselves. The unknown keeps expanding, and with it, so does our capacity for wonder. Perhaps the greatest lesson of the unknown is that existence itself may never yield to full understanding, and that this is not a failure, but a kind of grace. The human mind is finite, but the universe is not. There will always be mysteries beyond the reach of our instruments, questions beyond the scope of our theories, but within that limit lies beauty, for it is the not knowing that gives meaning to curiosity, the darkness that gives shape to light. Even in everyday life, we live surrounded by small mysteries. We do not know where dreams come from, why consciousness feels the way it does, why love endures beyond logic. We do not fully understand the beating of the heart, the spark of creativity, or the whisper of intuition that guides us when reason falls silent. These are the personal edges of the unknown, the inner frontiers that mirror the outer cosmos. Perhaps the mystery of the universe and the mystery of the self are one and the same. In the end, all science, All philosophy, all art, are acts of communion with the unknown. The astronomer gazing through a telescope, the poet staring at a blank page, the child asking why the sky is blue, all are driven by the same impulse, to touch the infinite, to draw meaning from the silence. And though we may never reach the end of our questions, that endlessness is itself the point. The unknown is not a wall, but a horizon. It is what keeps us moving, thinking, creating, wondering. When you look up at the stars, remember that their light is ancient and that the darkness between them is not empty, but alive with mystery. The unknown is not beyond us. It is within us, in every heartbeat, every thought, every breath that bridges matter and awareness. We are made of questions, and it is in our nature to seek. So let us not fear the unknown. Let us walk toward it, gently, with reverence. For it is the unknown that has carried us from the first spark of life to this moment, where we can gaze back upon the universe and whisper its own question, what are we? And perhaps, in the asking, in the stillness that follows, the universe answers not with words, but with the quiet, endless unfolding of itself.